As long as you learn something, whether you learn this didn't work, or hey, there has to be a better way, or hey, this worked perfectly. This is exactly what we thought. Any of those outcomes are good. Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes.
All right, everybody. Welcome to this episode of the LabVIEW experiment. I am your host, your special host this time, Norm Kirchner, and I am interviewing Sam Sam Taggart of SAS Workshops. And is it not the SAS Workshops, the LabVIEW Mastermind series?
Yeah, we do
Uh,
it. That's true. Yeah.
exactly. And what are the other claims to fame of things that you
Do
do?
LabVIEW experiment.
LabVIEW
This,
experiment, of course.
DevCon. I don't know. Probably involved in a few other things somewhere.
There you go. So we're turning the tables this week on Sam. It is the last episode of season 3. And whereas last year they did a bit of a recap with both Taylor and Sam, and I think, did y'all play like mimosa drinking games? It sounded like that was happening during.
I don't know. I do remember her bringing me a mimosa because it was the first time I ever had one, which was weird. I knew what they
Okay,
were,
so
but I never drank one. So,
there you go. Well, there's no drinking this time. I've gone dry for life at this point in time, so I'm just
cool.
high on life and caffeine.
This is actually just regular coffee.
There
Decaf,
you go. I was really tempted to do I was going to try to get something that looked like coffee grounds and say every time we were going to try to have an episode where we said LabVIEW 0 times. And every time that we accidentally said LabVIEW, I was going to look like I took a pinch of coffee grounds in the cheek. So that was about as
actually.
far as it was going to go. But we're not going to do that today. I don't know. There was definitely some questions when I was interviewing Sam last night in preparation for this, of this bigger question mark of Sam Taggart as the host of the LabVIEW experiment. What do you want out of this interview today? And what do you think the listeners want to hear most of all? And then we can dive into that and more.
I think the biggest thing is trying to give people hope in a way, because I feel like a lot of LabVIEW developers are kind of trapped in their situation. They work for a big company and maybe they don't necessarily see eye to eye with the direction things are going all the time, and they maybe feel overwhelmed and they're under pressure. And if you're dealing with legacy code, sometimes it's not always the way you would like it to be, and sometimes the tools aren't great. And so how do you deal with that, I think, is an interesting challenge.
I love that. That is way off the mark of where we were gonna go. Not necessarily. We had a bunch of different things, but I think having that be the theme is like there's a reason to hope. There's a reason to hope in a variety of different ways, even when it comes to AI, Sam.
Yep.
And that's
No.
the thing. If I my success by the end of this, if I can get Sam a little bit closer to AI is worth it and not just a boondoggle, I think we will have that and hope
Yeah.
combined together.
So I think you're a good person to this interview because you still have that light in your eye when you turn on the LED, right? That very first time you like type in a command and the LED pops on, it's like, ooh, right? But I work in corporations a lot and people they've lost that spark, right? It's the drudgery, it's the filling out Jira tickets, it's the sitting in Scrum meetings all the time. It's all of that stuff that
Yeah,
I
that's a really good point. That's something probably worthy of diving into in terms of things that crush hope, right? Or things that crush the enthusiasm in a system. And one of those things that, there's this question mark of busy work for busy work's sake versus is it actually somebody's like it's actually somebody's job, right? There are people keeping tabs on things. And that idea of what to do in the face of that. But maybe we leave that as a
well,
topic for maybe a little bit later in the
it's actually an
conversation.
interesting topic though, because so earlier this morning I was doing this mob programming thing. I do some stuff with like the Samman Coaching Institute, and we do some mob programming exercises.
How do you spell that? Because I saw that in a different interview and I wasn't quite sure.
SAMMAN. Yeah, it's a
S
cool cool group. Emily Bache is the one who's kind of the head of that. There's a bunch of people who are involved, but
okay.
we were doing this mob programming thing, and we spent a whole bunch of time trying to get this one test to pass. And at the very end, somebody made the comment like, it almost feels like the tests aren't working for us, we're working for the tests. And that is something that I see a lot of people like the process or the tool doesn't work for us. we're working for the tool. And that's why, like, for one, that's one thing that attracts me to the whole DQMH thing and being a DQMH trusted advisor and all that is
Mhm.
Fabiola's emphasis on developer experience, right? Why make things harder for
100%.
developers than it needs to be? Why not try to make that experience as good as possible? And that's one of my things is like, one of the things that drives me nuts working at certain places is, you're going along, there's a problem in the tool, and my instant reaction and philosophy is stop, fix the tool, encounter that problem once, and then never deal with it again. But I've
And
been where it's like, hey, that don't touch that. Oh no, no, you can't, and it's like, really? Well, it works for us. If it's not working, it's getting in our way. Why don't we change that? And a lot of
well,
places don't deal well with change.
Well, it's the doing something about it and then the cost of doing something about it. So let's dive into, as they say, double click. I don't know if I like that phrase or not. Like we're gonna double click into that thing, but we're gonna find something profound and get into it here. Uh, the bigger idea of that developer experience and something you mentioned in our kind of our prep meeting was people that are kind of like yourself. You were more of a test engineer or mechanical engineer or not a classically trained software engineer, myself included. And by virtue of LabVIEW, you kind of ended up working your way into that field. And there's a lot of times that I think the excitement that I get is when I remind myself that I am a programmer too. And whatever's going on in life, if it's something that I want for the family or something I'm doing on the web, I'm like, oh yeah, that's right. I can quickly make a program to solve my problem. And that idea of, I think it was Anton Sundquist from the last, is that how you pronounce his last name?
Yeah, I'm pretty sure that's right.
Yeah, and you had the interview with him earlier this season, so I'm going to do my best to kind of call back to all of the esteemed guests. Was like kind of creating your own tools, and that idea and that mentality of like if something doesn't exist in LabVIEW, taking the time to kind of create the thing, and hopefully there's the hooks for it, but create the thing in the way that you want it. Like for you, you created Blue based off of influence from another language. What's the
Python has a
Python
tool
one?
called Black. Yeah.
Black, exactly. So
And I
you
thought
made
blue
Blue.
and I blue,
Yeah.
yeah, that was like my small protest after they changed to green. I was like, no, blue.
Well, you can see the color of my office, and now we're Emerson blue again, so this is okay. Um, but the that bigger picture of, hey, we are programmers. Don't forget about that. And it doesn't, whatever we do, it doesn't have to be programmed for doing a thing and getting excited about creating something that makes you happy and then sharing that, much like the blue formatter that you made. And I think that's an interesting twist of, have you found that most people that when you advocate for, hey, make tools to improve your developer experience, like, hey, there's these problems in the LabVIEW project, or it doesn't operate the way that I want. Well, hey, great, go ahead and make a tool that makes your life easier and then share that. Are you finding that most people are like, it's not worth the time, or they just want to sit there and complain about it, or what's that work for you?
There's a couple things going on. I think one is short-sightedness and pressure. So, one thing I've definitely gotten is like, oh, don't stop and make tools. Like, it's the guy with the axe. Like, I can use this metaphor because I fight for it. It's like somebody, you walk along and you see some guy trying to chop down a tree and he's swinging an axe and it's so dull, he might as well be whacking it with a stick, right?
Yeah, yeah, for sure.
Would you like some help? Yeah, sure. Okay, great. How about you start with sharpening your axe? And the guy looks and he's like, are you crazy? I've got to chop down this whole forest. I can't, if I stop swinging the axe, how am I going to chop down all the trees? And you
Yeah.
just look at him, you're like, well, good luck with that, buddy. Like, I don't know what to do with that. When I encounter that situation, it's like, y-
There's
y-
a phrase that goes along with this that hopefully we can populate out. There are certain people in the world that no explanation is necessary, and certain people in the world where no explanation will ever suffice. And there's
Mhm.
probably a healthy amount of people kind of on the middle ground, but I think that really does that strikes that chord. But how have you had wins? Have you had experiments, in the name of the podcast of where you've tried to go that path and you had some resistance and you were able to get somebody over the hump where they saw the value in it? What were the wins? I mean, we can all complain about the losses, but
Biggest thing in getting those wins. So part of it is not asking permission, right? So I have don't ask
just do
permission.
it all.
Like a lot of times people are like, oh, well, I really want to do unit testing, but my boss wouldn't let me, or I really want to do refactoring, but my boss wouldn't let me. And my answer to that is like, do they need to know everything that you do? Like you can do like one tactic is like time boxing stuff and being like, hey, my boss is not going to miss a half an hour. If I take half an hour to go try to fix this problem, Nobody's going to notice because it's basically the equivalent of like taking an extra long lunch break or an extra long bathroom break or something, right? Like it comes out
Yeah.
in the wash. So time box it and go try and fix it. That's one thing. But the other thing too is like showing and not telling. If you tell somebody, if you know, there's some problem, you go to the tech lead or whoever, you're like, hey, we could solve this problem by doing XYZ. That's one thing. If you're like, hey, I took 2 minutes and I fixed this thing here, isn't it so much better? That's a very different conversation. Because when you just tell them, they in their mind, they're like, there's still this fallacy, I think, among some managers that like programmers, if left on check, will just gold plate everything and like, they'll just run off and go design all kinds of fancy stuff that we
Yeah.
don't need
Yeah.
and waste all our time. And there is probably some truth in that because I find those problems are the interesting ones to solve and often more interesting
Yes.
than the thing that I'm supposed to be doing.
Yep. Yep.
So there
Run into
is
that a
like
lot.
you do have to keep yourself in check a little bit and make sure that like what you're doing is actually serving the overall goal. But if spending 5 minutes saves you 2 hours, like to me, that's a no-brainer. Like it should not even like there should be no debate about it. Like go take the 5 minutes
I
and
think
fix the tool
even
thing. Yeah.
yeah, to make that there's a it's kind of the I would equate it to having kind of a process running in the back of your brain, actively searching out those opportunities. And I think that's for me that absolutely it kind of gets the that's an in the those are the things that like the LEDs blinking, like scripting makes me happy in LabVIEW, right? Anytime I have to create a little thing that like I have to noodle through, but I'm always actively searching. My brain's kind of always in this process of looking for what are those bite-sized nuggets. And I wonder how many people you run across that process doesn't exist for them.
Yeah, well, I feel like in organizations it doesn't exist though either. I feel like as an organization, like you need to have feedback loops and you need to have a way, like once a week, once a month, whatever it is, you have some meeting where everybody gets together and you just sit down and you say, well, what's working? What's not working? And if something's not working, like taking the I want to say I'm not quite sure how to say this, but like being proactive and saying, okay, this isn't working, let's change it. Because so many organizations just don't have a way to change things.
Right.
They're like, well,
Well,
that's
there's
we always do it. And I'm like, okay, well, why is that? Because we decided. I'm like, okay, we decided. Why can't we change our mind? And I think part of it, I think, is blame culture. People don't
yeah.
because to
What is
change
that?
your mind admits that you were wrong. And oh my God, that's so horrible. And like, and I get it. Like some corporations, like nobody wants to stick their head up because they're afraid of it getting chopped off. And I think that's a real thing sometimes.
Yeah, right. It probably happens a lot more in highly regulated industries, right? Because it's this question of like, what is the cost of risk, right? But I think that bigger question mark of should that become a something that just stops change, right?
Yeah, so there's some interesting things we can go into there. So one is the cost of risk, but also what's the cost of the thing that you are doing,
Yeah.
right? So that always has a cost. And what value is it adding? And also making invisible things visible. So example, you might work at a company and maybe they have some VI analyzer rule, whatever it is, that just like all kinds of false positives. You spend all your time going in and right? You run the test, a bunch of stuff fails. You're like, no, that's not a problem. You add your little VIN ignore tags, right? That takes time and energy and effort, right? And is it actually flagging things that are really a problem and going to cause problems in the end? And if it's not, why are you doing that? Right? Are you doing it just to check the box and say, well, we ran a VI analyzer test, we have code standards, great. That doesn't cut it for me. Like I look at that and I'm like, yeah, that's just like busy work. Like,
Right.
not
Like
saying
some of the things of like
like
the
there are good VI analyzer tests that actually catch bugs and catch things that really should be fixed, but there are plenty that are just nitpicky. And it's like,
yeah,
and there's a cost associated with that. There's a cost associated with all of that. And oh, like, the one that I was playing out was like, oh, coercion dots. I worked with a company that didn't like coercion dots. Okay, that's great. Until you do stuff with classes and you realize that every time you pass a child class into a method that expects the parent, you get a coercion dot. So now you have to put typecast everywhere to typecast into the correct type. And you're like, wait, like what's right? And even there, so like
well
the problem they're
let's
trying to
let's
address is like, okay, you have a I-32, you cast it to U8. That's a
yeah,
problem, right? Because you're going to
yep,
lose data.
yep,
So their solution is, oh, let's have a VI analyzer test that catches all the coercion dots. Okay, great. Except that A, that flags all these other things that aren't problems. So they got all those false positives. And then B, it's not actually solving the real problem because what happens is the developer does the same thing, I-32 into a U8, and just and now the thing stops complaining. Great. But now how are you going to catch that they did that? And
Yeah.
right. And like you can't tell me if you're that worried about people doing that. And I like the thing I is, oh, so in this one particular organization I'm thinking of, they they manage by emergency, they're constantly firefighting and they're always behind. And they're like, oh, but our code reviews are so thorough. And I'm like, I I have to I've yet to see one, so I'll tell you afterwards. But like I fail to believe that if you're that far behind, you're going to take the time to review all this code and catch that, oh, they're putting an I-32 into a U8 and like it's out of range and oh, it's going to cause problems. Right? Like
Well, in a
I fail
situation
to
like
see.
that, well, I mean, like you said, you identified some situations where it's valuable to find, right? That's a you're going to lose data, and so, but you've got a test that's just looking for the coercion dots,
Yeah,
and
I think it's
in a
writing better
situation like
text.
that, the incremental change would be to potentially update that unit test. And is that
Yeah,
something in the name of like, hey, those incremental and time boxing, just calling back to what you had previously of hey, is it better to change that unit test and show that it does a better job for it, or is it better to just say don't do those unit testing? Because in the name of like kind of test-driven design, well, I guess that there's probably a difference. Two tests, one for test-driven design or development, and this is a unit test. Those are two different
yeah, it's kind of yeah,
schools
this
of
is
thought,
more
right?
like yeah, and that's not even like yeah, this is more like static analysis, more like VI yeah, VI analyzer is like not it's testing your code, but it's not necessarily a unit test. But yeah,
Well, do you
just
find like what are you advocating for in the name of like what's Sam's ethos on this? Because we've heard you interview a lot of the people and a lot of their thoughts towards like this checking things off for the checking it off sake, right?
yeah,
And so if I'm doing test-driven development or unit testing, which there's I guess those are three different. Like, what is the difference?
there's
Like
all
if
different
you've
things.
got the
I
experience,
would say
educate
like
me.
do what you adds value and periodically evaluate things and say, ask yourself, does this actually add
Is it
value?
still
What is the
working?
if you can't clearly articulate the value that some practice or tool adds and it's getting in your way or it's taking up time and energy, then my next question is why are you doing it?
Interesting.
And maybe there's a reason, but
Well, that's
like
the thing.
if you
Everybody,
can't
so
give those
Dr. Tism was a
if the
presumed
answer
noble
is
intent,
yeah, if
right?
the answer is well, that's our process, okay, it's your process. You own the process. That means you can change the process. But I feel like oftentimes people are like they I think it's fear of change. I don't know. Maybe there's more to it than that. But
Well, one of those things that I ran into very recently, and this is something that I've been pondering on actually in the last 24 hours, is if there's if you notice somebody's doing something wrong or somebody wasteful, there's the cost of figuring out what to do in its stead, because presumably, once again, there's somebody went through and did I put it there because I thought this was going to be a problem, like the coercion dot.
yeah,
Okay, that's great. So we just get rid of that test altogether, or do we replace it with something? And then it turns into all right, who's on the hook for coming up with the alternative that
yeah,
does the better thing? And I
yeah.
think that's you like we all have varying degrees of empathy towards one thing, whether or not it's uh like what do you think is influencing your a lack of hope in you in that kind of situation, and what's a good thing to kind of to do about it at this point?
Yeah, I mean, I want to follow up on the previous thing a little bit first, though. Like, I would say, like, okay, should we do this at all? Like, one question to ask yourself is, what is the worst thing that could happen? Like, figure out, like, what is the worst thing that you imagine in your brain that could happen? And play that out and say, how bad is that? And that should drive your decision. If the worst thing you can imagine is, oh, there's a typo in our final thing, and like somebody notices it, okay, that's
Sure,
one thing, right? If it's like, hey, we're sending somebody to the moon, and like, if we screw this up, maybe they don't come back. Well, that's bad. We should
that's pretty
probably
scary.
do something about that, right? So
Yep.
it's that risk management side of it. So that was the first thing. And your question, sorry, can you repeat it again? Because your most recent part, because I got sidetracked. I was still stuck on the old thing. Now we're
That's
both
okay.
sidetracked. So
I
yes,
know
I
yeah,
think it was
this is
how
gonna be Rabbit Trail City here, folks.
yeah, how to restore hope. I think concentrate part of hope comes from having at least an illusion of control, I think. And so like focusing on the things that you can control, right? Like if you work for a giant company, changing their like big picture policy and procedure, probably not going to happen. But maybe you can change some local stuff, right? And maybe like I saw a presentation, and I think it was Albert DeWeese. It was at NI Week back when it was NI Week, and he was talking about biomedical stuff and about how
Yeah.
people often, companies often, there's a requirement, and the companies make it harder on themselves. And so, like something I always think is like writing software is hard enough without you intentionally making it harder on yourself. You don't need to do that. It's already hard. So like if
Like as a difficult requirement kind of thing.
yeah, well, it's like,
Okay.
okay, like something might say, oh, you need to have meeting minutes. Okay. Well, that could mean as simple as after the meeting, somebody sends an email out, right? Gets archived, there's your meeting minutes. But some place are like, no, we need to have this official document that everybody has to fill out and everybody has to sign it. And we have to like, jump through all these hoops. But the requirement doesn't say that, right? So that's a case of like artificially making your life more difficult. Right. So the requirement might be, okay, we don't want to do this U8 to or I32 to U8 conversion because we could lose data. That's great. But
Yep.
checking for coercion dots and flagging every coercion dot and making yourself jump through the hoop, that's artificially making it more difficult for you to write code.
Right. Because you just have to, it's just the maintenance, right? It's this things that end up happening for maintenance sake. And whereas, and once again, kind of this idea of teasing back to there's so many different kind of degrees of things that you do for testing of code. Like the idea of a static analysis test is like VI analyzer,
Mhm.
right? And then you've got unit testing, and then you've got test-driven development. Is it development or design? It's test-driven development, right?
Yeah.
But the idea with test-driven development is everything is based off of an explicit software requirement. And so there has to be a value. Is that how you do your test-driven design up front? Is like
Well,
everything is like a value add to the functionality of the specifications?
yeah. So basically, test-driven development is a way of it goes for starts with breaking down the problem, right? So you take a look at your requirements document, you find one small requirement, right? And part of it is thinking about how you're going to test it first, right? So you end up with something that you can test. Because we've all written code and then gone back later and said, oh, I'm going to test that. And you're like, oh, wait, this is really hard to test, right?
Yeah, that was what somebody, one of your interviews, I can't remember who it was, but maybe it was Anton again as well, of the like coming in after the fact. No, it was the person who's not a LabVIEW developer, but coming in after the fact, after the code's
But
already done, and then trying to do TDD on that code base is a nightmare, right?
yeah, writing unit tests for existing code is hard. Writing unit tests for code that doesn't exist is easy because you get to define the interface, right?
Yep.
So part of it's about that. It's about building stuff incrementally. So to your point, like if you're following it in a strict sense, it's designed to fight that tendency to like gold plate stuff and add features that you don't need because every feature that you add, you have to write the test first, and that's work. And so if you don't need the thing, you're not going to be inclined to write a test for something that you don't need. And
Gotcha.
often, like when people gold plate stuff, they add in this functionality that they think somebody might want in the future, but they never test it, right? And so then you get to the future, and even and A, half the time you don't need it, but B, when you do need it, sometimes it doesn't work because they never tested it. Because they're like, oh, well, they might want that in the future, but they're not using it now, so we're not going to test it. Right. So
Yep.
it's wasted effort that could be gone into something else in the meantime.
So in the name of wasted effort, right? It's time spent, it's investment. And I think a lot of these things, if I kind of extrapolate, it's, come from somebody was burned once, like the meeting notes. I can very
Yes.
easily see somebody at one point in time was burned one time by somebody wasn't in the meeting or they didn't approve and like there was a disagreement on like the outcome of the meeting, right?
Mhm.
Therefore, every meeting subsequently in the meeting notes, everybody needs to approve all that from there because of that one mistake that one time. And I think that's an interesting, once again, the empathy towards why annoyances are existing in the first place. And similarly, so like the idea of gold plating something, I would say it comes from a prediction of technical debt. And I know that you're really, really big on like don't over design anything. And there was a comment from one of your earlier episodes as well from season three was perfection is not achieved when there's nothing left to add, but there's nothing left to remove, right?
Yeah.
That's such a great one. I wrote that one, or I took a comment on that one, and I was just like, okay, I really need to let that permeate. But I think that idea of there's a difference between gold plating and trying to reduce the technical debt of when something right? We have no crystal ball to see the future, but each of us have different strength binoculars,
Mhm.
right? And we're all kind of forecasting of what's in that forest ahead of us. And so, what are some of those things that you've done that somebody else has said is gold plating, but you've realized, like, no, this is my experience talking, and I can see into the future better than you?
I think part of it is having an I so there's two skills that are vitally important for this discussion. So one is having an idea of what's easy and what's hard.
Okay.
Change later, right? Certain things are easy to change later, and certain things are hard to change later, right? So like versioning
Yep.
stuff is something that like can be hard to add later, right? But like, if you get that done and so like when I come into a company, like the very first thing I do is I do the versioning and the build pipeline. I do those two things right away because I know down the pike that's going to save us. And you would be surprised. It's 2025, and I go into companies still, and they hand me a flash drive that's got
Yeah.
folder version 1, folder version 1.2, 1.1 with fix, right? And they're like, we have no idea what's running on this thing, right? And so in
Yep.
that case, yeah, I could go like look at their code and just fix the thing that they're talking about. But the very first thing I do is like, no, we're gonna have this version because to me that's like the baseline. Because if you can't like track the changes over time, you don't know what works and what doesn't, and it doesn't let you do those experiments of like, hey, we're on version 1.1, let's release version 1.2 and see if it's better. If it's not, let's roll back. If you don't have that versioning, it's really hard to do those things and to do experiments like that.
But inherently, what you've done is the exact thing to someone else. Like you slowed them down because copying a directory is way easier in their mind, once again, toward than having to go ahead and have it in source code control and check it in and have a comment and all that. Like you and I both know, and hopefully our listeners do as well, those things provide value because
Hmm.
of the potential future situation. And
Yeah.
that's probably a really good one. If that's like the very first thing you do, that sounds like you've got a lot of experience walking into those organizations. Well, like, can you, like, what's a really salient example that you just drop in front of them and they go, all right, fine, towards doing that change and making sure that's now part of their workflow? Like, how do you convince people in that you've done?
Well, I mean, I think you just look at like, have you ever lost work, right?
Yeah.
Anybody who's lost work, right? Like right? I saw the thing that I saw recently. I will pick on someone. I'm not gonna mention their name. Don't know who they are, but I like them anyway. You're all right. But they were working on something and they were doing some JSON parsing or something, and they had to make changes to like 4 or 5 different files to try something. And they tried it and it didn't work. And they immediately went back and started re-editing those files to put them back the way they were in 4 or 5 different places. And I was just
Yeah.
pulling my hair out, like, what are you doing? Like, no, we should go back into Get and throw all those changes. Because when you put it back, you're never gonna like get it exactly the way it was. You're not gonna remember all, oh, I changed this, I changed that.
Yeah.
Like you're gonna so like eliminating that little bit of error proneness is huge. And like,
And
okay,
that came from you watching them do a thing. So there was a bit of an observation it sounded like you needed to do so that you could put in front of them a prime example of something that would have been
yeah.
better
Yeah,
had
and
that
I mean,
not
he
been the
changed
case.
5 VIs and he remembered everything you changed. And okay, great. But let's say you changed 10 VIs. Let's say you
Oh,
changed
sure.
20, right? Like at what point? And like the other thing too, like one thing, lots of people use source code control. They don't necessarily use it well, right? So there's lots of people who are like, oh, I have source code control. I check everything in at the end of the day, and that's my backup. And that is certainly better than nothing. It's better than zip files. If that's what you're doing, great. But there's a
Yeah.
better way, right? To enable these types of experiments and stuff, to enable like, if you release often and every commit's really small, and you can go back and have customer notices a problem, you can get them to test 2 or 3 versions and they can say, hey, between version 1.1 and 1.2, that's where you introduce the problem. And you go and you look and get and you say, hey, 3 files changed in that revision. That's
It's got
really
to be in
easy
there.
troubleshooting. What if version 2 works and version 1 works, and there's 20 revisions between there, and there's 100 files that change? Which one do you want to debug? Right? It's much easier when it's like 1 or 2 commits, and it's like these couple files. So, and I mean, that to me, that's the biggest benefit of test-driven development well,
Mhm.
there's a couple hidden benefits, but one hidden benefit is less time in the debugger. I spend like almost no time debugging it because when I want to add a new feature, I add a test. I go, I write some code, 5, 10 minutes, done, hit the button, run. If the tests fail, I have a choice. I can spend some time debugging. I can go look in and sometimes I do and I'm like, oh yeah, typo, easy, fix, done, test pass,
Yep.
everybody's happy. Sometimes I start down the path and I'm like, I really don't know why this is doing it. I can throw it away and try again. It's easy. It's like a get restore. Okay, let me try again. Let me try something else. That didn't work.
Oh yeah.
Or I start down the path and I'm like, okay, I'm gonna add this feature. Oh well, I gotta change these other 10 things. I can be like, okay, stop, go back, let me fix these things one at a time first, and then let me go add my feature. I have
So
the
where do you find that crossing point of, because yeah, as you've mentioned in previous interviews too, for reference, I was listening to all of the interviews yesterday at 2.5 speed. So Fabiola at 2.5 times speed, that's a heck of a feat. So
thing.
and but one of the ones that I did catch in that is that you did agree that not every implementation, once again, the name of value add, requires doing, hey, I'm going to have all my tests, right? There's certain things like you said, hey, you need to have source code control, but maybe not every application or every place that you walk into needs to have. You're going to start off with all the lists of tests, or is
Well,
that pretty de facto, regardless of the size, in
a
terms of
great
things that you?
example for a place where like I think anything that's going into production generally should have tests, but
Yep.
there is a skill that I think is undervalued, and Darren hit on it, I think, a little bit in his presentation. There's the value writing cheap little throwaway scripting tools to like go do something in your code. Like, hey, you know,
Yes. Yes.
I want to go make sure that all of my I don't know all of my string controls show the display type, right? They're not
Yeah.
showing. I
Display.
want to
Yeah.
show them all. You can write a scripting VI in 2 minutes to traverse a directory, find all the VIs, find all the string constants, change that. Do you need to
100%.
test that? Right? Probably not. You can write that, run it. Your code's in Git. If it screws up and does something wrong, you can
Yep.
put it back, and you can visually inspect that really quickly. Open up 3 or 4 VIs, be like, yep, I caught them all. Done. And it's low risk if you miss one. Okay, well, then because maybe you traversed the structures the wrong way and you forgot that a
Sure.
flat
Sure.
sequence structure isn't an actual structure, and it's right. Like there's some weirdness in VI server, but like
Yep.
those little things, do they need tested? Not really, right? Like I think there's a different level of testing that you need for like cheap throwaway tools like that. A cheap proof of concept. You're throwing together a UI just to show somebody like, hey, we can do a
Oh
dialog
yeah.
box with a tree control and this and that, and it could look like this, and you throw that. Do you need to test that? Probably not, right?
No, that wouldn't be test, but that sounded like you were talking about, even depending on what application that you're on. It sounded like you were saying that there were not just throwaway code, but there were other applications that it might not make sense. Or there's even applications though that don't really lend themselves well to, because there's a difference between unit testing and test-driven development, right? Every test-driven development is not necessarily a unit test, right? Those are different things, right? Educate me.
Test driven development kind of has to do with how you break down the problem and when you write the tests. But there's also like you can do test driven development. It doesn't necessarily specify that you write unit tests. You could write like larger behavior tests. The key to
Okay.
test-driven development is a feedback loop of like, hey, before I start, I say this is what I'm doing, and I have a way to
Mhm.
verify that, and then I go do the thing, and then I check. So that to me, like the big thing about test-driven development is the feedback loop. And if you're doing something like, for example, you can do quote unquote test-driven development with a piece of hardware, right? Like I need to read a value from this DMM. You can do test-driven development by saying, hey, I'm going to read from the DMM. I expect it to 10 volts, and you hook up a 10-volt power supply, and then you start sending Skippy commands to the thing until you get back 10 volts. You're like, okay, great, now it works, right?
Yep.
And if you send the first command and you mistype it and you hit enter and you send the command and it spits back, an error or the wrong
Something,
number or
sure,
something, you're like,
whatever.
oh wait, I didn't do that right. So to me, I mean, it's great if you can automate all those tests because then you can keep
Sure.
the loop and you get all the benefits of refactoring and all the benefits of having unit tests and regression testing and all that. But to me, the key piece is that feedback loop. And I mean, that feedback loop is like essential. It's like part of everything. So it goes back, like the whole CI/CD thing is a bigger feedback loop of like, hey, I'm writing this code. I need to get it to my customer so they can verify or validate, or I always get verification and validation mixed up. But like, right, one is
Sure,
like,
sure.
we did what we thought, what we thought was right. And then the other one is what we thought was right is exactly what the customer wanted. right? And there's no mismatch there. Because you can do everything right on your end, and there was miscommunication between you and the customer, and now the customer's not happy because you didn't do what they wanted, right?
Right. So you've got that alignment based off of the tests themselves that you can kind of bounce back and forth. And it sounds like you collaborate with those customers to define what that is. It's not just Sam's list of things, right?
Yeah, yeah, exactly. Yeah.
So one of those things that kind of comes along the line of collaborating with the customer and justifying something is not a gold, like anybody that you walk into that's never done those actions before might declare that as that's software engineering gold plating. We don't need that crap, right? But I think there's this idea of technical debt. And I love thinking about technical debt like literally a credit card because part of the idea of, hey, you don't need to do that. I'm fine. I'm fine. And anytime somebody says that's not necessary, I'm fine. I see that as, hey, you're using a credit card, right? You're building up the technical debt and like I'm paying for this. I get to walk out of the store. I'm not stealing this. I get to move forward and but as you and I can look at it and say like, no, you're driving yourself more into the red. And in the future, you're going to have to pay off that debt, right? You're going to have to, it's a bank account, so it can go into the red or into the black as it was. And different people have different kind of exchange rates almost for certain things, right?
I-
And
yeah.
like I said, that's a really good mental model that I like to look at in terms of like, yep, we're not in any problem right now, right? In terms of what like whether the language or the tool or even a relationship in life. How do you look at technical debt yourself in terms of once again, gold plating is a I'm preventing technical debt because I've put a simulation in there, right? You made a mock framework that you said eventually it kind of went stale and you never used, but you still probably make simulator classes for
Mhm.
hardware abstraction, and that's something that is, you know, it's like, hey, you're spending time on that because you believe it's valuable, other people don't. You're saying you're preventing technical debt in the future because the cost of change and being able to test. So what are some of those ways that you rank? Like, what's if I were to like put Sam's exchange, you know, the stock market of like what's the value of certain things in there? How do you rank technical debt? What do things cost for you and all that, I guess.
Yeah, I mean, I think technical debt, part of technical debt is it's a communication metaphor, right? It's an attempt to communicate the trade-offs that we're making as engineers to the business people, right?
Hmm.
And
Or even fellow engineers, right?
yeah, but I think it fails for one reason, and that is the way we as individuals treat our credit and our credit card is
Mm,
very different than the way that companies treat credit cards and treat credit, right?
okay.
So like companies are much more likely to go out and buy stuff on credit than an individual, I would think. That just seems to be the way that a lot of companies work. And especially like startups, right? You're a startup, everything's on credit, right?
Yeah. Well, it's like it's cash flow. It's not about how much money you've got. It's how much, as long as you're money in and money out, and you just, you know, you can spend $10,000 of debt every month, but as long as you pay that old debt off, that's fine, right?
Yeah. And also too, like there's so the old original metaphor, I think, was made about like intentionally choosing, right? So I have a choice. I'm here right now. I want to build, I don't know, a new app, a new social media app, right? Let's
Yep.
say I'm building a social media app, right? I have two choices. I can, from the very beginning, make sure it's super technically robust and sound and do all the design work up front, super secure and all this stuff, but it's going to take me a long time to get that out the door. Or I can intentionally take some shortcuts, knowing that, like, yeah, I have to fix those things later, but get something out the door in order to get feedback that, hey, I'm on the right track, that I'm building things that people want. Because the other danger with that thing taking very long is I'm building things that people don't want. I spend all this time building and securing features and nobody's using them,
Yep.
right?
No,
Versus if I build those features incrementally and one of those features doesn't work out, I can throw it away. And I haven't spent all this time making sure it's super robust and secure and I covered all the edge cases and everything, right? So
so
there's a bit of that, and it's an intentional choice. And you're making the trade-off that I'm trading off potential future work to get quicker feedback. And that's very different than the other type of technical debt that we see, especially in the test and measurement world, where I've got this machine that I just had a company call me up the other day. They had a Windows 7 machine running one of their test sets and it just
yep.
blew screen to death, right? That's technical debt because they could have upgraded that. They made decisions along the way not to upgrade that machine
Right.
and it eventually bit them. And they gained in the meantime because they were able to keep using the machine. So
Right. I think one of the things that confuses me when in those conversations of technical debt is that people get frustrated, like, oh, why do I have to rewrite this? As opposed to just merely accepting the reality of, like what you said, you made a conscious choice. Don't be upset now based off of the choices that you made previously when you were very clearly saying it is okay to kick this down the road. And I think all those conversations and those human interactions, those kindergarten skills, right? Of, hey, let's just be realistic about why we made the choices and let's move forward into what's the solution at this point in time without feeling salty about the fact that you've got to rewrite code. And I think it kind of gets, sorry, go ahead.
oh no, no, you just sparked something. I had two things I want to say. One, there's a guy, G. Paul Hill, he talks about rework avoidance theory. And people really want to avoid rewriting things. And to me, that's just like it's kind of crazy because the whole reason we do stuff in software instead of hardware is so it's malleable and we can change it. And yet we're afraid to change it because we're like, oh well, I put work into this thing, so I don't want to have to change it. And it's that total sunk cost fallacy thing. So that's one thing. The other thing too, I think sometimes like certain types of technical debt, like right, I've got this old Windows 7 machine or whatever. I like to think of it as like, listen, technical debt is the difference between if we were to do this project today, how would we do it versus how did we do it back then? And it
Yeah.
doesn't really matter why we did it the other way back then, right? Like it doesn't matter if we had good ideas, bad ideas, whatever. It just it happened. We can't change that. What we
Yeah, I see
can
a lot of people trying to make like
do
either
going
excuses or
forward
apologize for how it was done in the past. But the reality is like it's okay that it was done that way. You don't need to qualify this person didn't know or throw them under the bus. It's all right. We are where we are, right?
this is what is, yeah. But I think too, a lot of that, to take it back to our previous discussion about corporate culture and stuff, I think a lot of that stems from blame culture.
So
People
yeah,
are
that
afraid to say, oh, well, we did something wrong because they're afraid they'll get blamed. And they'll be on the chopping block the next time there's layoffs or something. If people are like, oh yeah, they made this bad decision 5 years ago and now we're paying for it and blah blah blah. And it's like, and I just like that whole thing is like, I just don't care.
well,
I'm
is it
just like,
blame or ownership? Like there's the idea of like I made the problem versus the blame, which is another person. And when we rebranded, it was, it wasn't just a color thing, but also we tried to take on this persona of kind, bold connectors. And everybody got tripped up on the like it's all marketing fluffy, but I really personally speaking, I kind of leaned into it to try to understand it at a deeper level. And it kind of goes to this idea of a blame culture where a blame is you're just a bull
avoid
in a
is
china shop pointing without the fingers pointing back at you. But there's also this concept of the kindness of it, which is a bit more of a balanced view. Take ownership of your part. But there's, I think it's like Jocko Willnick, right? He's got his podcasts and book and everything, but it's this idea
yeah,
of extreme ownership,
yeah, yeah.
right? And that idea of like, you know what, there might be the problems, they're there, and there might be a blame culture, or people want, are you seeing people don't want to blame, or they're making excuses for why it is right now? Is it excuse or blame? And then where does ownership fall into that for you?
I
Or
think it's
extreme
more
ownership?
excuses. Yeah, I mean, I think too the extreme ownership thing is really great because it's take control of what you can, right?
Yeah.
And to me, that's the whole point of like the whole like focus on what's going forward. And like looking back can be valuable sometimes. Like you can look back and you can see patterns, right? Like, hey, we've had this bug in our code. Okay. You can look at that and you can say, well, it's out came out of this pattern. Great. Let's find everywhere else that we did that pattern and go fix that before it causes problems again. That's a good use of looking back. If you're looking back to figure out, well, who do we point the finger at and who gets dinged on their next annual review or whatever, right? That's a bad way to go do that.
Yeah, and
Or
that makes it hard to get more people into an organization like that because you could probably feel when that's the style, like when you're being interviewed or when you ask questions in an interview, right? And that's probably a thing to kind of extract, like why are the problems here, and see what that person responds. Do they respond back with hey, in ownership aspect of it, or do they come back with a blame aspect?
we get defensive, yeah. And also that also leads to a lot of other things. So places like that tend to have like lots of layoffs and things like that. And like people, the thing I've noticed is places that have had lots of layoffs, people tend to hoard knowledge. Everybody wants to be the expert and they want to be the LabVIEW guru or the database guru or the right because they
Yep.
in the back of their head and maybe it's subconscious even they're like if I'm the expert at this one system they'll never let me go because they need somebody to take care of the system, right?
Yeah, that's such an
Which
unhealthy
doesn't
way
actually
to,
work, right?
yeah.
Because they don't care, they'll probably get review anyway if they really want to, but But yeah, that's the thinking I think that goes behind it. It leads to a lot of things, and it leads in like really toxic things. It can lead to like self or sabotaging each other, right? Like you've got two employees who both want a promotion, and employee A has having problems. Is employee B going to take away from their work and their output to go help employee A, even though it's better for the team if it looks better if they do their thing and the other person doesn't? Right? There's a lot of inter office politics and stuff that come into play sometimes.
Yeah, it's tough. I mean, I've been grateful enough to not be in one of those situations, but I hear these horror stories of just something the interpersonal inner workings for all of it. But like you said, there's a whether you're testing or whether you're measuring or whether it's like you're just kind of feeling like what's the barometer of an individual place and how well is it going there? Let's go ahead and turn the corner a little bit in terms of things that we're talking about, and I'm going to just ask some of these questions that AI gave me
Okay.
that I recorded notes from while I was driving back and forth to San Antonio yesterday, listening to all of your podcasts at 2.5 speed, and I took my verbal notes and I threw it into an AI model and said, "Give me 10 questions." Was it attached to notes to reviewing season 3 of the
Awesome.
LabVIEW experiment? Please review and give me 10 great podcast questions. So we're
I
gonna
like the
see.
way you're using AI though, human in the loop. I like that.
Okay, okay, okay.
So
So
it's
yeah,
an
we'll talk about.
augmentation, not a replacement. I like that. That's good.
So you do like AI because every time I see your LinkedIn posts, it's constantly this is bullshit.
Uh the hype around it, I think, is BS. But yeah.
All right.
Hey,
Well, let's see what it came out with here, and let's try
here's
some of these questions, and we'll see if we can burn through some of them so that we make sure that we don't get trapped and not get through seeing how AI did. So we've got all right, measuring the experiment. How do you personally measure the success or failure of a LabVIEW experiment? Or of a LabVIEW experiment, especially when failure might be the biggest success. Because even in the title of this, everybody heard we believe that failure is it's a good thing. So how like at what point in time, if everything is a success, how do you declare failure?
so assuming an experiment is not fatal, right? So first of all, if you're doing experiments, you want to set them up
Oh,
so that if the worst happens, right, it's not fatal, right? So that's the first thing. But the only other way that an experiment
no
can
death.
you don't learn anything.
Okay,
As long as you learn something, whether you learn this didn't work, or hey, there has to be a better way, or hey, this worked perfectly. This is exactly what we thought. Any of those outcomes are good. The only
nice.
bad outcomes are, hey, our experiment, like we miscalculated, was fatal. That's bad. Or we
A
did the
blanket
experiment,
waste
but
of
we
time.
can't draw any conclusions from it at the end. We didn't learn anything, which is actually really hard to do, right? Because at the very least, you learn that like that thing did not produce the output that we want. That's
Right. That
learning.
experiment was a bad experiment. Let's not do that
Yeah.
one again. So, in that name, were there any LabVIEW experiment podcast sessions that you would declare a rank that one didn't work out so well, or one that was like a shining example of working out well? Let's talk
I
about the
don't know if it
podcast
was an
itself.
intentional experiment, but I definitely there was one where I forgot to hit the like, record button. And then we went back and I added that into Zoom so that now as soon as I start the meeting, it automatically starts recording. So that was
Amazing.
one that was an early failure.
Okay,
Although I will
but a
say
learning
I've
because
been
you
the
learn
guest
from it.
on a podcast at least once where that also happened. So
Ouch. We are recording. Hold on a second. Let's all double check here, folks. All right.
uh,
I still see the
now
red
you're making
light
me paranoid, but it should have started.
on.
Actually, I did not check
Microphones are.
when we started, but yes, it is set
The
up.
mic.
But that goes to like some of the things about like building tools and stuff. Like I forget where I was with somebody and they were like talking about like something and it's like, oh yeah, well, as long as the developers are careful, that's fine. And I'm like, I would like to create systems that don't rely on the developers having to be careful, right? Let's build a system where success is the default and you have to try in order to do screw something up, right?
What would that be?
Well, like they had something where like, oh, you've got to remember to copy this over here and copy it over here and rename it a certain way and do this and do that. And I'm like, you could write a tool to do that
Yeah.
as opposed to like, right? Oh, well, I realize this is hard, but it's only a couple steps and the developers can remember that. And I'm like, yeah, they could, but they can also
But
forget and they're
wouldn't
human.
it be better to not do that?
Yeah, it's
All
like
right.
it's just a general engineering principle, right? Of like you can engineer stuff such that like the fail-safe state is good as opposed
Yeah.
to the default state is bad.
I mean, by definition of name, right? It is the fail safe
Yeah, yeah,
state,
exactly.
right?
Yeah,
Exactly.
yeah.
All right. So let's see what we got. That's a good one. All right. So learning styles and scaling. In your experience, what's the best way to scale deep, scale deep, skills-based LabVIEW learning. Do we need more cookbooks or instructors or something entirely new?
I think mentorship. I think
Yep.
working next to somebody, and I just posted something on LinkedIn. I saw Jason Gorman writes a lot of good posts, and he had something, and it goes back to that whole feedback cycle again.
Yep.
If you want, if you, as an organization or manager or whatever, right, you want certain behaviors out of your developers, whatever it is, right?
Yep. Yep.
The shorter that feedback loop is between they do something and they get feedback on was that the right thing or not, the better. That's why like corporations that do like annual reviews, right? It's a horrible practice because the person does something awesome in January. When December comes around, you do the review, you completely forget about it. They're demoralized, right? And then maybe they did something bad in November. And now you're harping on the thing in November, you completely forget about the thing in January, right?
So when's the last time you told Taylor how awesome she was?
Not often enough, actually. I hope she knows that I appreciate her. But yes, Taylor, you are awesome.
Taylor, thank you again for all the work that you do on this. Little Easter eggs. We're going to see how much we can do. Sam has swore that he would not click his pen throughout the process
I
of
think
this,
I've been
which
doing it anyway.
oh, well, I haven't caught it, so we're all
She'll
right.
tell me if I did, I'm sure.
How about this bigger picture? Staying on learning styles and scaling, because you did a course of like a LabVIEW hands-on at CU Boulder, not the one
Yep.
that I was at. And it's
That was
always
the
this
second
twist.
one we did. I did one with
The
Nancy.
second one was, yep, that was you and me. But one of those twists of uh, learning can go really, really well when there's a professional in the room who really likes to teach and to go through and guide, as opposed to somebody who's just going to sit passively waiting for a hand to be raised. But that unfortunately is a requires that expert to be willing to give their time and mentor and to go out and to do that, which is really so difficult. So what is that? Like I see that as a big dilemma in terms of like I want that for every student to walk away going, heck yeah, shut up and give me more LabVIEW. Uh, but of course that requires someone like yourself or another trained individual or somebody a passionate, let's call it passionate individual there at being able to put that out there in front of someone. So what do you think about that? Like the best way is to have somebody there, but in the absence of that, what do you like? What do you like to put in front of people? That's not just a cookbook, do this step.
Oh, that's challenging. Uh, let me see. I want to answer something that you didn't ask a little bit, but I think that one of the reasons, so you gave an educational example. Inside
Mhm.
companies, you have trouble getting people willing to do that mentorship role and that
Okay.
teacher role and excited about it. And part of it, I think it goes back to, and this is not necessarily a problem we can all solve, but I think it goes back to the individual compensation part of it, right? And how we rank people and we judge people based on their output. And if I'm the senior developer and I'm getting judged on how many lines of code I output,
Yeah.
it makes it hard for me to stop and say, hey, I should go help this junior over there, right? Even
Yeah.
though that's better for the team, and that might be the behavior that the company wants, what they're incentivizing is that senior to then keep doing their own thing. So
Have
that's
you run
one
across people that have been like really dinged for not having enough output, but they're spending a lot of time mentoring?
yeah, yeah, that definitely happens. So
Interesting.
so yeah, so that's like figuring out a way to incentivize that is one thing. And then content wise, keeping people engaged if you don't have that instructor right there. I
Yeah.
like video courses. I've got several video courses on my website. I think they're good. I think you get a little bit of the video brings a little bit of enthusiasm there, a little bit, right? And
Yep.
also I think there's a book called The Four C's or something of education, or no, Teaching from the Back of the Room, but it talks about the four C's. And there's a way to structure. The Samman Coaching stuff is really good about that. There's a way to structure learning stuff so you keep it engaging, you keep people doing. So, like a lot of it is exercises and stuff. So, for
Yep.
example, I joined a company recently to do some work with them, and they had training, and it was training on how to use Perforce. Okay, and I haven't used Perforce in a long time. Okay, but their training was a bunch of slides and pictures of Perforce. But you had to take this before you could actually get access to Perforce. So I'm sitting there reading the slides and I'm like, okay, that's great, but I can't go in and click around and play with things and see, well, what happens if I click this? But what happens, right? That's not a great way to learn,
Yeah. It's more
right?
controlled because then they don't have to worry about guiding you once you do the wrong thing, but at the same because that's the challenge that I run into because
To me, like the thing to do is to encourage. The theme of the podcast is encourage people to experiment. So set up a sandbox. You're onboarding a new employee. Give them a sandbox where they can go, give them their own Git repository. They can check stuff in and out all they want. They can write whatever code they want in there and give them a few exercises and let them just go play. And people actually learn really well when they're playing, right? If you treat it like play, because there's pressure when it's a formal classroom setting, right? Because there's pressure of like, I'm going to get evaluated at the end and all these things, right? And that just detracts from the learning process.
So in those situations, you're learning a lot. It seems like you read a lot. It seems like you are learning other languages. You're in the Samman, which, in a variety of different ways. The How often do you find that it's the learning experience or the experiment needs to be in line with your real task, or having something totally orthogonal, like create a battleship game, right? It's like that's you're doing something totally different than what the end product is. What do you like in terms of that split in terms of that learning style? Do you like when it's like directly in line and it's like, hey, it's more purpose driven and I can see a direct hop to how I'm going to use it? Or do you like it when it's kind of pulls you out of that zone?
I think you need a mix. So I think you do need deliberate practice time, like some percentage of time a week, whether it's one afternoon or an hour here or there, lunch break, whatever it is. You need time to directly just practice things. But part of it is too, there's so many things you could learn, so many directions you could go. So I always try to like tie things back to either A, like, hey, this is going to benefit a project I'm working on right now, or
Mhm.
B, this is something that I'm exploring a new thing, but I see how it might benefit something, right? So like, maybe I'm not doing CI/CD right now in my work or something, but that's something that like, hey, that might have some value, so I'm going to go explore it. Versus also like maybe I'm doing a project right now where I'm doing something where I'm using SQLite or I'm using test stand or I'm using JavaScript and I've never used those
Sure.
before. In your off time, buy a JavaScript book or go read it. Go do a JavaScript exercise. Go generate a website that does XYZ just to kind of get an idea of how that works. And that directly translates. The CI/CD stuff might not translate for a while. It might be more of a long-term thing that someday we'll get into the CI/CD thing and then I'll go implement that and I'll have an idea of what it is. So it's kind of
Gotcha.
both.
So a little bit, but even in those situations, it's staying technical. But like you said, I think it's interesting. I'm kind of curious. Have you ever done like something associated? You said you did like trail running, climbing, and guitar. Have you ever created like used one of those other learning outlets associated with something that you're passionate about? And did you find that that really, really helped motivate you or distracted from what you were trying to do for the business purpose?
Okay, so connecting me learning technical skills connected to one of those, like doing a website
Right,
for,
instead of it being associated with something that you're explicitly in, like I said, if you're learning a SQLite, right,
yeah.
that it's purpose driven towards one specific thing that you're doing,
But I
and
could write it
versus
down.
like, hey, I'm gonna learn SQLite, but I'm gonna do it associated with something like for my kid's school or something like that.
Those thoughts have definitely entered my head. Like, hey, it would be really cool if I could learn SQLite. And for me, part of it was like running my own business. Like, it would be really cool if I could learn SQLite and then use that to like create some CRM or something for my business. And I did do that a little bit. So like I read a SQLite book and then I'm able to like pull down like, all my financial stuff from QuickBooks and I can run SQL queries and pull stuff out. And so that was useful in that other realm that's not like LabVIEW based.
Yeah,
So
yeah.
but also, like, like right now, the big thing I'm learning is web skills. I've been learning some JavaScript and CSS and stuff because, like, it's everywhere. And, like, yeah, I could see myself putting together, like, a website for, rock climbing or something or something like that. But then those skills also can translate to LabVIEW. Like, I had a
Oh
project
yeah.
recently where they had a serial and they wanted to be able to, like, toggle inputs and outputs and stuff. And we just made a little web page so anybody could walk up, log onto the same network as the serial, pull up a web page, and toggle an output. That was kind of cool. And that was like web based and JavaScript based. So,
Love
it
that.
has some applicability. And I saw something just recently where somebody who had embedded, they were using Grafana to view data, but they had a way to embed the Grafana into the LabVIEW front panel. So you can do all
Interesting.
kinds of cool graphs and look at data and stuff without doing any LabVIEW. You just have this like X control
Em-
that
Embedded web page.
yeah, better
Yeah,
web.
there's a WebView 2 control. So
Yep.
you should, based on that statement and something you said earlier in terms of sandbox, for those of you listening, keep your eyes. It's probably come out in a couple months, but I'm doing to evaluate LabVIEW, doing a fully web-based experience evaluating LabVIEW through Amazon Web Services, virtual machines, and it's going to be a 3-day sandbox kicked off with a 90-minute to 2 hour norm talking to you about evaluating LabVIEW in all the different dimensions of what it exists. So hopefully that fits the bill for what you're looking for. And even off of this interview that we're doing right here, it's going to influence me to go ahead and say, hey, what kind of experiments or what kind of fun exercises should we let people do to learn how to do TCP/IP, right, as a fundamental skill in LabVIEW or something like that. So keep your eyes peeled for that.
To tie that back, that is a great example of show don't tell. Because I feel like that's something I've been saying all along is like LabVIEW and I marketing LabVIEW to people who don't know LabVIEW is a lot of telling and it's hard
Yeah.
to show them.
Yep.
And so
Yep.
that's an example of here, go immerse yourself in it and be wondered by all the great things that LabVIEW does, and then come back a true believer or whatever, something like that.
Yeah. Well,
But
I'm looking for
that's
converts. My
yeah,
title is Evangelist, and so I'm trying to make pick your fellow prophets of the wire as it was.
yeah. But yeah,
Um,
no, I mean, I've been I'm sure you know, I've been advocating for that for a while, so that's a good thing. I'm glad to see NI doing that.
All right. So speaking of things that we're trying to take care of and if they go well or bad, Fabiola mentioned if you're a firefighter, you might also be an arsonist.
Oh yeah.
Has that ever hit home for you? Like, at what point in time were you the arsonist that you turned into the firefighter for?
What point in time was I the arsonist that I turned into the fighter? I see that in other people, so I see like
No,
accusations
no.
where,
This is about you, Sam.
yeah, I know. I'm trying to think. When have I been the arsonist? I don't know. I don't. I often feel like the firefighter because, as my friend Christian Butcher always says, right? Like I would complain about the quality of the code that I inherit, and he's like, "Yeah, well, if they were doing it right, you wouldn't inherit it, right?" So I am the outside firefighter coming in to put out the fires.
Sure,
Uh,
sure.
when I was at Westinghouse, I was kind of the intern. I'm trying to think of a time when I actually.
Fires at a nuclear place is not really
I'm trying
a
to think
great
of a
thing.
time when I caused a problem that then I also solved.
All right, so anybody listening, put in the comments of the YouTube video,
I'm
did you
sure there's
inherit
some fellow
Sam's code
coworkers out
and
there
you
who
had to be you had to pick up his
problem that I
fire?
caused that I then, yeah, I don't know. That is a good question. And I'm thinking long and hard, and I'm actually really trying to think. I mean, I'm not. I have absolutely made mistakes. I'm trying to think of a big mistake that I made that was really big, where I then came in and became the hero. Yeah.
So anybody that knows where Sam's been an arsonist, if you put it in, you're the first person to leave a comment, you get free SAS workshop, right, Sam?
Yeah. Oh, yeah, absolutely. Yeah. No, I mean, I'm sure, and I'm sure, like, I've worked some places where, like, yeah. Here's the other thing. I wrote a blog post once, like, it's okay to cringe. If you look back at your old code and you do not cringe, that means you haven't learned anything since you wrote it.
Oh,
So the
interesting.
cringing is actually a good thing because you look back and you're like, wow, I can't believe I did that. That means that now you know a better way.
Yeah,
So if you
absolutely.
ever look back at old code, you're like, that was 100% like you can be like, I did a really great job at the time. But if you're
Yeah.
like, I would do exactly 100% the same thing today, that probably means you haven't learned it. I mean, I don't know, maybe you are the one in a million that got it 100% right. That's, you wouldn't do anything different today, but like, yeah.
Well, I think the twist is it's that last qualifier you put on it with the 100%. Because I go back, right? I am very fortunate that I can go back to code because of my mentor Tim Jones back in the day and the principles of s'mores. There's a
Mhm.
lot of stuff I go back on and I'm like, that was nice. But I think that twist is the 100%. What else would you do different, right?
Yeah.
Would that change? And I think that's the twist of there's got to be something in there because otherwise you're exactly right. You haven't learned anything.
Well, there's also
So
I go back and like, thank God I did it that way because it's easy to change now. Like
yeah, exactly.
that is very much like, yes, I followed the s'mores principles. That's good. Right. But the fact that you're going back and changing something says that like you didn't get it 100% right. Or
Absolutely.
maybe you got it right at that particular point in time, but things changed out from
Hey,
underneath.
yeah, there's new features.
Which is
Yeah,
like,
100%. Like the tree control API and some of the stuff I did for the data retention for each node. I'm like, oh, I've got sets and maps now. That's a great example of, man, I
yeah.
wish I could make myself time box my time and get in there and change
Well,
that.
we were talking about empathy earlier, and I got my empathy and tech t-shirt. So when you look at old code, you have to remember, and it took me a little while to realize this, because like I inherited some code and I looked at some of the stuff that I was doing. So the very first project I inherited was old code from like LabVIEW 4 or 5. And
Mhm.
literally everywhere, like the guy, when he wrote it, they didn't have control references, and he had a screen with
Oh yeah.
24 graphs. So he literally had a for loop 24 times each graph. duplicate all the property nodes in each case and wire them up. And I'm looking at that, and this is like I'm on like LabVIEW 8 or so, 7 or 8 or something. I'm like, there's an easier way to do this. Why would he not do it this way, right? And I'm thinking this guy must, be an idiot or whatever, right? Like that was literally my thought process. He's like, yeah, they didn't exist back then. I was like,
They
oh,
didn't have that.
right. So every time I see somebody doing something, like for example, now I've worked with a company that got these. Uh, they've got some VI analyzer type stuff that they do, but they wrote their own custom VIs, but they're not custom VI analyzer tests. And I'm like, well, maybe when they wrote that, that feature didn't exist. Or maybe that feature existed and it wasn't well advertised and they just didn't know about it. Because
Maybe
I'm
that's the
looking,
whole
I'm like,
thing.
well, why are you running these things outside VI analyzer? Make them custom VI analyzer tests. But maybe they didn't know that, right?
Yeah. Yeah, it's a lot of like if you've never seen it done good or done well, I don't know the grammar, right? But if you've never had that example put in front of you, it just makes sense to do it certain ways, right? It's just your own creativity and the ether that it's between
Yeah.
you, right?
And in their defense, even though that was cumbersome, it worked, right?
Yeah.
So like there's a factor of like, yeah, we did it and it wasn't the best way, and maybe there's a better way, but it met our needs. So who's to say that's wrong? But like as an outsider, it's easy to come in and say, well, it could be better. And that's awesome. And we should I would hope people want to strive to make things better, but at some point too, it's like it's good enough. So
All right. So let's move on to the we're burning through the list here. We'll make this one short. LabVIEW in Python, right? It's been like maybe 2 years, it seems like, since you 2 or 3 years since you really started doing a little bit more. You started with like the advent of code. I
mhm.
remember like that advent of code post that you're like, hey, I'm gonna try to do this in Python while the rest of you
Yep.
go ahead and do it in LabVIEW. What has been things where you thought it was gonna be good and it didn't work out well? And things that you didn't think you were going to use it for and you're going to stay in lab, you're like, you know what? I'm just always going to go ahead and do that one part in Python.
Yeah. So I thought there would be more of a full disclosure, I've done some Python stuff. I haven't done a whole lot with integrating LabVIEW and Python. It just hasn't come up. I thought
Sure,
it would
sure.
come up more because a lot of what I do, a lot of projects I end up doing are these data collection things. I think I've said this before, where like you collect all this data, you throw it into a CSV file or whatever format it is, and somebody else opens it in Python and does all the analysis. I always thought that like, hey, we could do that analysis in LabVIEW, but if they already have the Python scripts, you can call the Python nodes, and instead of doing that analysis offline, you can do it right there on the spot in the same GUI. It's very easy. You don't even have to rewrite the analysis code. You just call it using the Python node. And I thought that would take off, and that did not. Uh, but one place I've kind of used it, sort of in conjunction with LabVIEW, I built a whole bunch of CI/CD tooling and stuff, and I
Okay.
built a
Yep.
web page for that. And the web page is built in Python, so that's kind of
Oh,
interesting. Yeah.
interesting. Now that is you hand rolled that Python to get to that point so that it could
It's a
make a web page, or
template.
how did the
It's a templating agent. So I don't know how much you know about like Jekyll or Hugo or one of those things, but basically it's like the templating agent is basically you write a bunch of markdown files and then you run this program and it like converts it into a web page, like a static web page generator.
Okay.
And so this is a Python based one. So you write your markdown files, and in the markdown files you can write like little snippets of Python and it'll do calculations and stuff, and then you can run this Python code on it and it generates a static web page. So that is
Interesting.
actually something that I've been thinking about, is that we don't have a static web page generator built in LabVIEW, and that's an interesting project. I don't know that we need one, but that's just an interesting project that I'm like in the back of my head, like it could do that. And you mentioned web stuff too. The other web thing I've been trying to do is figure out. I've got LabVIEW running in Docker containers. It'd be really cool to run some kind of LabVIEW web service in a Docker container. I haven't quite put all those pieces together, but that's on my list of things to do. And I'm not quite sure what the use case for that is, but
That'd
it
be
seems
very
like an
interesting. Well,
interesting technology use. And it's like, hey, could you make something useful out of that? And I'm sure you can. I just don't have the use case yet.
one of the things that you mentioned, I'm kind of curious because this is probably a lot of us that are still listening. If you're still listening after all this time, thank y'all for
Yeah,
sticking
yeah,
around. I think we still got plenty more to go
yeah,
through,
yeah,
but the
yeah.
one of the ones was the, hey, I could do that analysis in LabVIEW and you'd get it immediately, and you're like, that didn't take off. Can you talk more about that? I'm kind of curious as to, like somebody once said, a CSV is like a warm blanket. It just makes people happy and comfortable. And I'm not saying don't make the intermediate file, but doing that analysis live and in LabVIEW, what was one of those things where that experiment you said didn't take off? How'd that go? Tell me more about that.
I think it was inertia and lack of demand. So it was one of those things where I had a great idea as a developer. Oh, it would be really cool if we could do this, but there was no market for it. There was no demand. Like the company was perfectly happy with the way they were doing it, and so it just like it went nowhere.
They just saw
So
no. Interesting.
yeah,
Fair enough.
and and since then I haven't had any other jobs where it's come up, so it hasn't really become an issue. But
Okay.
yeah,
All right. So speaking of skills that you've got and experience had, let's talk about refactoring superpowers. What would you say are your refactoring superpowers, and how do you keep tech debt from becoming an emotional baggage? Well, that's
I
okay. That's
think
total like AI fail right there.
yeah. So refactoring superpowers. I think refactoring superpowers. Number one, I think of like the Boy Scout rule or like the dirty dishes rule of like just cleaning stuff up as you go. Like,
Okay.
people are like, oh, we have this refactoring sprint or whatever. And I'm like, yeah, that's great if you need to make a big change, but you should just constantly be cleaning. It's a habit. So that's like
Okay.
the first big thing is like refactoring should be a habit. You should practice it. So I watched a video recently by JB Rainsberger, who was on the podcast a while ago, and he was talking about the more you practice, the more it chunks, and you get into this thing of like, so if you think about it, right, driving your car, there's a lot of actions to driving your car. There's turning the steering wheel, there's hitting the gas, there's hitting the brake, right? But when you drive to work in the morning, you get in your car and you don't think about it till you're at work. You're not thinking about
Yeah.
all those little individual
Total
decisions.
autopilot. Yeah.
Refactoring is the same way. When you're making a big change to your code base, there's a bunch of small, tiny steps that are involved in that. And if you have to stop and think about each one, it takes a really long time and it seems this big daunting thing. But if you're just like, I'm here, I need to get there, and you go into this like driving mode where you're just like, okay, let me do this, and you know all the steps, it gets much easier. And so you get that by practicing. So I'm a big fan of practicing. I've got a whole bunch of katas on my website and my GitHub or GitLab. So I highly encourage that. And I have a workshop on it even.
Is that,
And then,
those are like refactoring katas?
yep.
Interesting. So like tell so like for somebody like me, educate me and everybody else that is unfamiliar with katas. You've mentioned it before. That what's the 30-second elevator pitch for katas?
Kata simply comes from martial arts and it just means practice form. So a kata in code is a practice problem. So one is the Gilded Rose kata. I did a presentation at GLA Center. It's basically like there's a setup. You're running this store. Here's this inventory management system, and you want to add a new item. And you look at the code and the code is just awful. So you get to say, how can I refactor this so that then adding the new item is easy?
Okay.
And so you look at the code and it's just that particular kind of, it's like a nest of like seven deep case structures,
Yeah, yeah.
right? And you're like, and so the practice is how I've got this big nested case structure thing. How can I simplify that? And it's learning the little tricks of like, oh, I can combine these two cases and I can check this out here and I can move this check out here because this case structure is redundant because I'm never going to end up in this case and things like that.
Yeah. I've seen that one of those things about refactoring that I love about LabVIEW, and I just ran into it yesterday. It's so often that you see the visual design patterns and
Mhm.
that you don't really get to see nearly as clearly if you're working in text. And those things jump out to you ideally of like, oh, wait a minute, they're doing the same operation again and again. Or like the cleanup for me, like that idea of trying to get a diagram clean matters so much because once you clean it up, you will naturally see patterns
Pattern.
evolve. And then you're like, oh, wait a minute, I can totally turn that into not that math or not that complexity or make it more scalable,
Yeah.
modular, reusable, extensible, or simple. In all those instances. So that's very interesting. There's something that we started doing at NI internally that Travis Ferguson has been at NI for a really long time, and he came up with this idea of a batting practice, very similar to kata, undoubtedly. But the twist was the batting practice is a something that me as a person who uses LabVIEW to do RF stuff, I can do in 30 seconds to a minute, hands down.
Okay.
But
Cool.
if I give it to somebody else, one, the idea of the batting practice is that even the professionals, the reason we call it batting practice, even if you're a professional, you still go to the batting cage. You still do these things. You still periodically do that part of it. And there's still even a batting coach there who can look at you and kind of, independently verify or give you tips on how to improve, even if you're a professional. And so like I said, katas probably take that same similar tack, but for the batting practice, it was, I'm going to give you a challenge and I'm going to justify why it's relevant and I'm going to let you loose. And I'm going to 2-minute video. You go crazy for 10 minutes. And then I'm going to show you a 3-minute video of me doing it the fast way that you might not have even figured out in 10 minutes. And then a 2-minute wrap up video, kind of just talking about here's the things that you should have seen, things that you should have learned, and things that you can do for next time. Like the things that accelerated. Like the great example is like quick drop keyboard shortcuts, right? I was able to do a lot of stuff really, really quick because just boom, boom, boom. And sounds and smells a little bit more similar to katas, but this has a little bit more structure around it. And for somebody like if anybody listening to this that has an organization and you're trying to get people to develop faster like you, coming up with your same batting practices, then you can be that coach. You're in the room with them and you're reviewing their stuff after they're done with their 10 minutes and they kind of talk through, hey, here's what I did. And then you can give that feedback. And that we've seen that go really well. And Travis has taken it to a new level, just about like out of RF territory and just into DAC, right? People that are just starting out with the basics of it. And he's done like the same set of 4 questions over and over. Like you choose like a set and then you repeat it. And it seems contrived, but much like batting practice, theoretically speaking, if you didn't get it done in the first 10 minutes, but it should take a minute, the second time you do it, you should be able to get it that much faster until you burn it down because it's such a fundamental, pick a fundamental concept like cleaning up a diagram or rearranging things.
Yeah, that ties into the previous thing of like, the driving thing. You're condensing all those actions and they become automatic.
Yeah.
Becomes muscle memory.
Yeah.
And
So
that
you
ties
got,
a whole bunch of things together. So, but going back to the refactoring thing, I think the biggest mistake that I see is people take too big a step. They try to take these giant leaps, and the giant leaps are great. If you do the giant leap and it works, awesome. Problem is, if you come up short, recovering is kind of painful. And
yeah.
so I think the smaller steps thing, but also going back to your point too, and I think we hit on this earlier, the value of doing the batting practice and having an external coach is that they see things that you miss. And
Yeah.
also they know what good looks like, right? So if you're in
Yes.
the batting cage and you hit, I don't know, 4 out of 10 balls and you think that's awesome and you're happy with that, a coach might come in and be like, if you change this one thing, you could hit 8 out of 10. Like you just don't know, right?
Yeah.
You don't know what good is, and you don't even know, like if you're not watching other people and you don't have an idea. So if you're working in a company and you're like the only LabVIEW developer, or you're a small team of LabVIEW developers, but nobody's ever worked anywhere else or done LabVIEW anywhere else, you don't know what good code looks like. You don't
Yeah. Well,
know.
that's why with the katas, I was kind of curious. How are people judging their answers in the katas for what you've got on the website? Do they submit them, or is it just you show them your solution on the other side? Is there a video that you have talking through your solutions?
Yeah, so they're meant more for like self-study and self-practice.
Hmm.
I have an online course where like I present like some topics and ideas. And so there's this the Samman coaching style uses these a lot. So like a Samman coaching session is basically 2 parts. So the first part is we would do a lesson, and the lesson is like multiple parts, but basically it's like we introduce some concept. Hey, I'm going to show you this refactoring for like simplifying case structures, and I do it, and then you go in the code and you do it, and then we talk about it.
Yeah. Yeah. Yep.
That's the lesson. And then the Salmon part is then we spend 2 hours as a group doing a mob programming session on your code base. And we find areas where we can use this thing in your code base. And then you try it on actual real code.
Oh, wow. That's very intensive. That's really large
Yeah.
concepts as
Yeah.
well.
Yeah. Because part of the problem is the batting practice stuff is really good for getting that muscle memory.
Yeah.
But
100%.
it's an idealized situation where it's really easy and it's just one step and it's super obvious what to do. You get in your real code base, finding those opportunities is hard because like, oh, well, this doesn't look exactly like what I did in batting practice. And maybe it's a little bit different or there's some small complication. Okay. And the coach is there like, okay, well, if we remove this part, this looks like your batting cage. Now you can do that. Right. So
Gotcha.
yeah.
Oh, that makes a lot of sense.
Yeah.
It's very insightful, um, or profound, right? Um, but I think,
Oh, the other thing I want to mention too, though, and I forgot to mention this about the taking smaller steps thing.
yeah,
Uh,
yeah.
there's this thing called the Mikado method. I think I've talked about it before. I encourage everybody to go look it up. But like part of it,
How do you spell that?
Mikado.
Oh, okay. Another
Just
Japanese
like
thing.
when I talk about like time boxing things and stuff, when I'm working on a project and I'm adding some new feature or something, I have a
Hmm.
mental timer. And if it takes me more than like 20 minutes to add some feature, like my mental timer goes off and I say, hold on, this is more complicated than I thought it was. And I take a step
Yeah.
back and then I go to this Mikado method, which is a way of like breaking it down into smaller problems. And so you spend some time and you graph out the problem. You end up with this graph of all these smaller problems to solve. And then you
Yep.
go solve those small problems. Each of those small problems takes like 5 minutes. And then you crank through them and then you end up
Exactly.
solving the bigger problem. But
You
yeah,
like that's a lot of a learning method where like you're doing each one of these things and you can see how they're fitting into the bigger picture,
yeah,
right?
exactly. Yeah.
Yeah.
Eh,
So in terms of like the what you've put online for like I said, you're posting on what's the website again? SAS workshops or is that the
yeah,
one?
it's workshops. Yeah, there's a blog there and yeah.
Okay.
Yep.
But so one of the things that you mentioned in one of the in a previous episode this season was contributing to the community, and also you've talked about skills that are not necessarily just LabVIEW code. So in one of these questions that this pulled out for me is like beyond code and content, what other unique ways do you think people can contribute to the LabVIEW community that we aren't seeing yet? What kind of tertiary skills and contributions do you think are warranted?
Uh, well, that's not code and content. So
Well,
one,
not LabVIEW code. Let's talk about that.
yeah, yeah. Well, contributing community. One is organizational. So like
Mhm.
organizing user groups and stuff, organizing GDevCon. We're always looking for help for those type of things.
Okay.
Encouragement, encouraging people to present. You see somebody who has good ideas, and you're like, hey, I would love to see that presentation at GDevCon or something, right? Like just those little things are really useful. So that's like
Do you,
encouraging content. I think just being a participant, showing up at GDevCon, showing up at local user group meetings and just
yep.
participating in any way, I think is a useful thing. I'm a big
Especially the user groups, because if there aren't bodies there, or if you're just logging in, it doesn't feel like you're building a community. And I think one of those, there's a book that I'm reading. It was about habits of a family, like and one of those ones is like if you try to do something good for your family and it feels awkward, it should, because if it didn't feel awkward, that but you know it's good, you would have been doing it already, right? You can feel good about it, but it can feel awkward, but you can commit to it being a good thing. And I think sometimes these user groups, especially as they continue, they're growing from where they were, where they kind of had stagnated for years. And there's a ton of them. Like NI has hired 2 dedicated people to cover user groups just to make sure the user group communities are flourishing. We need people to go there and not just be absorbers of the content, like reach out, get to some degree of socialization at these user groups so it feels like a community can go a long way, especially if you see somebody sitting in the user group and they're not connecting with anybody and you're just talking with stalwarts of the user community, right? Part of the way that these communities grow is if you're, kind of trying to make it feel like a home for more people, which it starts with showing up and then kind of engaging at that location, right?
Yeah. So that brings up another one that just occurred to me, and that is being a connector. That is a great way to help the community. If you know somebody who has an FPGA problem and you know somebody who's an FPGA expert, make the introduction.
Yep.
Right?
And you know what? I'm gonna take this. I'm gonna take this quick moment to do a shout out to the LabVIEW Community Training Initiative. Right. If anybody's listening and they don't know what it is, go look up LabVIEW CTI, and there's a bunch of videos online. But we need people that have C++ or microcontroller programming experience, because right now the CTI is predicated on the good graces of all the hard work that Derek Bomarito has put into all of the cool firmware that's available and the robustness of the API. And he's been kind of on his own. And we absolutely, if somebody out there listening to this has or knows somebody that likes LabVIEW, but also likes microcontrollers, get involved, get on the LabVIEW Discord for the CTI, and let's see what we can do about trying to get some help for Derek to continue to advance all the things and features that we want on the microcontroller for the CTI, because it's such a cool opportunity. But I would say that's definitely a non-LabVIEW but still code contribution and people to contribute on that front, because it is so cool to see the community rallying around this. But that's one of the areas that needs some more love.
Yeah. So on that note, right, CTI is open source. So helping with open source projects, opening
Yeah.
issues, adding documentation. If you're using an open source project and you're like, oh, that was complicated. I didn't know how to do that. I figured it out. And you look on their site and there's no documentation, submit a pull request with some documentation. Um, Big one that people don't do is star projects. We have projects, and you can look at the top projects on VIPM, and there are places that have 40, 50,000 downloads and like 10 stars.
What is this?
40 or 50,000 people downloading this thing, and only 10 people thought it was really worthwhile to go and click the star button. That just
Oh,
crazy to me.
well, I never even think about it because I'm not going to the website to get it.
Yeah,
I'm
I
just
think that's
using.
the problem. People download it from VIPM, the package manager itself, and they don't start. So that is feedback. I think I've had that for Jim, but I'll add that here in case Jim's listening or Tom or anybody. If there was a way to start in the VIPM desktop executable thing, that would be a lot better.
Yeah, no, that would be very interesting. Or even like a little bit of a nag reminder. Hey, these are the things you got to install. Consider. I'm sure people would probably get pissed off at that, but you never know. I mean, I guess that's part of the feedback mechanism. Can you provide any feedback? That's interesting. I've
Also,
never
I
thought
mean, it
about that.
makes it more valuable for the community because if you can go on there and you can see this packet, there's two packages that do the same thing. Right now, you can look at the downloads, but if you could look at the downloads and the stars, and you could look at that ratio, be like, hey, yeah, this one might have more downloads, but like the star ratio is way off. This one, like, I have some projects that have like 5 stars, but they only got like 50 downloads, and it makes me feel really good because it's like, hey, there's this other one that's got like 10,000 only has 5 stars. Like, so
People. Well, there you go. Sam said he wants encouragement. So everybody that gets anything from Sam, go to the VIPM.io and give him some extra stars.
yeah.
Help
Or
help
anybody
Sam know
else,
that
really.
we
Like,
love him.
if there's a package that you really like that you always install on all your machines, go start. I
Yeah.
mean, it does,
What's
it's kind of a vanity metric, but it does make the people who create the packages, it feels good when you can see that and be like, yeah, people appreciate it. So
gives you hope?
buy them a cup of coffee too. Like some of them, like Enrique, I know has a buy a cup of coffee thing, and Olivier has his Patreon thing. Like, go support people that way too.
Yeah, the Patreon, I think a lot of people know, but the buy a cup of coffee, Filippo Piercia, I don't
Mhm.
think he's on the community too much anymore, but he's still out there in the community, posting on LinkedIn. But he has it's a website, Buy Me a Cup of Coffee, which is you can give like micro contributions to
Yeah.
people's things. So I didn't know about that until I saw Filippo's stuff, and I'm like, oh, that's great. But I knew about
Also,
Patreon.
you could also
All
do
right.
that if you see him at GDevCon or something. Be like, hey, I really like your appreciate your project. Buy me a cup. Can I buy you a cup of coffee?
Yeah, oh yeah, quite literally, yeah. All right. Favorite teachers and lasting lessons. Who are your favorite most influential teachers, both inside and outside of LabVIEW, and what did they teach you that still shows up in your work?
Yeah, outside of LabVIEW, I had a teacher, Dr. Mao at the University of Pittsburgh, and he taught me two lessons. He was my grad student advisor, so awesome guy. The two things I take away from him, one is, and I tried to emulate this. I taught for a while at Colorado School of Mines. I very much tried to emulate this. He didn't care about grades. The emphasis was really on, I want you to learn and remember this stuff.
Yeah.
And I thought that was great. And like, so I really tried to take that away. And the other thing was he was very into cross-disciplinary things. So I took a thing, you'd probably enjoy this. It was a class called Control Theory and Neuroscience. And he
Oh,
taught it with a biology professor, and they looked at how does the brain work and how do our models of control systems work and how do they overlap and does the brain act like a PID loop when doing certain actions and things like that. And it was really cool and interesting. And he did a bunch of other that cross-pollination Renaissance man thing, I think, is something that we've
yes.
lost as a culture. And I think that often like the best ideas come from taking a good idea in one place and pulling it out and being like, what can we learn from that and how can we apply it over here? So
100%. How about in the LabVIEW space? Who'd you learn from LabVIEW that you really appreciate?
I love Steve Watts' book. I have to say, when I first read it, I was in the architecture astronaut type stage of my journey, and
Wait, he has a book?
yeah, he has two books. He has a book on coupling and cohesion, which is more recent, but it's an older book, Software Engineering Approach to LabVIEW.
Oh,
But what I immediately realized, his code in that looks very simplistic. It's very simple code, which actually I've come to appreciate as I've gotten older. I like simple code. At the time, I thought it looked too simplistic. But what I realized and immediately recognized is I was doing all this object-oriented stuff, and he basically invented object-oriented programming without calling it objects. The stuff he was doing, the encapsulation, the data hiding, all that,
yeah,
he was doing all that stuff, and he figured out how to do that with just plain old vanilla LabVIEW. And I thought
yeah.
that was really deep. And I think Steve has a very deep understanding of LabVIEW and how it works. So
Yeah. Well, and things that matter about it. So yeah, definitely kudos
yeah.
to Steve. The funny thing is there's probably no audiobook to it, but I do a wicked Steve impersonation, so I kind of want to get it just so that I can do a recording of me trying to sound like Steve Watts in his Cockney accent.
You need to become a star now on Kindle or something. You should go read it.
There you go. That'll be fantastic. All right. All right. So coming to around number 8, watching others use your code. You've talked about walking around and seeing how people use your code, and you wrote, what's the most surprising change you made after seeing how someone actually used your tool? So you made stuff and they ended up using it in ways that you didn't expect. So you like to watch how people use your stuff. What
Yeah.
did
So two stories here. I want to write them both down. Sorry, taking notes just so I don't forget. The first story is a more recent one. So you mentioned the auto formatter. I made the auto formatter, and I think this story goes to illustrate that you testing can only get you so far. So I built it. I wrote a bunch of tests. I thought the tests are actually pretty robust, and I still think that it's a pretty good test suite that I have. But pretty quickly, somebody came back and said, "Oh, well, if I run it on a directory that has a file that's password protected and it throws an error," and I was like, and that was something that like no amount of testing would have caught that because I wouldn't have thought to write that test.
yeah.
Right? Because I don't password protect VIs. I hardly ever encounter them except like in NI stuff that's in VI lib. And so it just didn't occur to me. So that was one where it's like, and I didn't get that from watching him. It just came back. The
Mhm.
other scenario that I think is really interesting, illustrative, is some changes I made to somebody else's code, but that it came from watching. So I worked for as a gig for a mining company. They were doing soil sample, and they had this machine, and it had several stations, and kind of like a conveyor belt. It wasn't conveyor belts, it was like spinning tables, but same idea.
Yep. Yep.
The way the operator interface was, it was obviously written by an engineer for engineers, not for the person who's actually
Operator. Oh, yeah.
the operator, because there was one tab that had all the motor controls. There was one tab that had all the pumps, one tab that had all the valves, and it had like 4 or 5 stations. Each station had a pump, a motor, and a valve. And I was like, I would want to control like individual ones. And like there was something like every time you start up the program, you had to go to this tab and click this, and you had to go to this tab and click this, and then you had to go here and home the motor. I'm like, do you always do the same thing? She's like, yeah. I'm like, why? Like, why can't we out of it? So when I rewrote it, I basically rearranged all those controls so it was like by station. So you could look at this station, you could see what's going on at this station, you could flip to this station. And then I also like had the homing sequence that you had to do every time you started up. I'm like, it's an automated system. If you always do that every time you start it up, like build it in. So we built that in. So you didn't have to remember to do that anymore. So like little things like that, I think, and it's just it's the not thinking like an end user and not observing like just that 5 minutes of observation told me like yeah that there's a better way.
Is that is the phrase cowpath engineering an actual phrase or something that I just think is an actual phrase?
uh I've not heard that, but I know immediately what you mean, right? Like I remember sitting in a meeting at Westinghouse once and they were talking about how they built this new parking lot, and they built these sidewalks that went from the edges of the parking lot to the door, and the door was in the middle, and everybody kept walking in the middle. And so it was like, why don't we put a hedge there to do that? And I'm like, why don't you just pave the path?
Yes. That's that. There was a university, I think it was Berkeley or something. Stephen Loftus Mercer um, mentioned it to me. Is basically they built all the buildings, they built no sidewalks, they just put grass in, and then they look where the grass died, and then they put the sidewalks in. And I
Yeah.
think there's a lot of that kind of cowpath engineering. It's tricky because like this idea of like the waterfall method and come up with all of your requirements first. Um, I think a lot of people will go and just until you have something existing for a period of time, you don't know what's going to matter most. And I think leaning into that idea of, hey, we're going to do a thing and we're going to be okay with throwing it away. We're going to be okay. We're going to deliberately make it beyond a proof of concept, but we're not going to try to make it the thing that lasts 5 years. It's kind of like British TV shows, right? They're made to run for like 2 or 3 seasons, and that's it. As opposed to every American show tries to hang on as long
Milk
as it
as
can
much as
until it's
possible. Yeah.
until it's terrible, right? Um, and yeah, Alias is a great example of that. If you ever watch that show, watch to the end. It's like, oh,
Oh
uh,
yeah. Good.
it's great up first, and then they just kept trying to figure out how to keep it going, and they
Oh,
just should
okay.
have killed it after
Just
season
watch
three,
the
right?
first 3 seasons. Got it.
Yep. But that idea of even in engineering of, hey, let's find out that good upper bound and let's just program to that and have a fully fledged plan to re-architect once we have a better feel for
Mhm.
where the things are going to really, really matter in that. And I've never heard anybody talk about it like that, but it feels like that would just be more sane, but nobody wants to buy into part of the plan is programming it all again.
Yeah. But like I said before, like it's software, it's malleable. That's why we chose software.
But
I
that's the difference. There's a different, like, I think it's that the exchange rate, right? It's the cost. It's the perceived cost of, right, the hey, I'm willing to change it. I absolutely, yeah, you have to adjust this. Great. We want to do that. We want to do that. But it's that, but we're throwing something away. It's that sunk cost, right?
cost
That,
fallacy, yeah, absolutely.
yeah.
Gets
So
you every
tricky.
time. Um, I want to tie up one other loose thread though to tie back. So I talked about the Newmont thing and like the people. Here's an interesting thought about that. The people did not actually realize that was a problem. So people are very adaptable and they get used to things, and they got very used to using the machine that way, and they just assumed that's the way it was, and they
Yeah.
didn't. And it goes back to the idea of not knowing any better. If you're in an isolated LabVIEW team and you're writing code and you're constantly fighting LabVIEW,
Yeah.
and you just don't, it just never occurred to you that like you don't have to fight it. You get used to fighting it. And so much so that you defend fighting lobby. You're like, it should be this hard. Like you want to make it easier? That's crazy. Like this is just the way it is. And like, yeah. So it's very
Yeah.
interesting what people can get used to.
Well, it's the cost, right? I think that there's a cost of like how do you get exposed to that? And even when I was like in UT San Antonio yesterday, they have a Mach 7 hypersonic wind tunnel, which is madness, right? It's like 7 times the speed of sound. It's amazing. But they have a piece of code that I've been using this phrase of organic growth.
Mhm.
Right. And organic growth can be healthy or it can lead to like it's just use that mental model that it's going into everybody's mind right now. And that's exactly what happened. They used the basic level techniques and they kept applying those basic level techniques because nobody ever educated them on, all right, you probably want to stop now because you've added 14 wires in parallel. You might need to add more. That's going to have cascade effects. And so now it's at a point where they know enough, and I don't want to look at them like somebody screwed up because nobody did. They just took the skills that they had. But now it's this question mark. If I introduce somebody into the lab to help them, we need somebody to help them in the right way. We don't need like this third tiered threshold of complexity because the students are still the ones that have to understand it and maintain it. How can we take this thing that they have figured out like what matters and what doesn't, but not maybe make it the best program that it could be, or even the way that an architect would do it, but make it in this in-between zone of it's not using the base level techniques. It's not using the techniques like, hey, everything should be a DQMH module. No, you've got to find this happy middle ground that's going to give a robust program, but still be approachable by these students that can be learned. Where LabVIEW is not being seen as an anchor, it's more of a hey, it's worthy of refactoring at this point, but take all of that exists that we're going to kind of throw away, but not see it as throwing it away. These are the paths that exist, and now we're going to pave over them.
Yeah, I think that's interesting. I think my advice to a group in that situation is it's easy to look at the code and be like, oh, it's a mess, right?
Yeah,
Everybody's seen code that's a mess. The
yeah,
trick I think is figuring out where your ROI is and start with what is one simple problem that I have, and can I figure out what in the code is causing it? And can I fix that one thing?
yeah,
As you start fixing things and you build that momentum and you slowly start changing it, I think the mistake that people make is they get overwhelmed and they're like, oh,
yeah, absolutely.
they're like, let's throw the whole thing away, or I need to go spend a month refactoring to go fix this thing. In reality, you can find a couple little things and just slowly start fixing things. And like one of the big things I always find is naming. I go in and the names are all over the place and two things are named similar that aren't similar, and like or vice versa. And like you're like, yeah, like let's start fixing those little things. Like naming's one, little things like adding descriptions to places, documenting things that maybe are unclear, uh, little things like that. Like replacing old patterns. So you see somewhere where
Yeah,
like they didn't
yeah,
have the conditional output tunnels, so they're doing the thing with the shift
yeah.
register that fix that. Just go in and replace that with that conditional output tunnel.
Just
Just
that
those
one
little
thing.
things. You do enough of those things, and the code slowly starts looking cleaner. Even just the act of like going in and just straightening all the wires, like to your point earlier, it makes patterns suddenly appear.
Yeah, absolutely. Or magic. I love the phrase that I've inherited called magic numbers, right?
Mhm.
These constants on the block diagram has
Yeah,
that same kind of effect. And I would say one of those that I can add into that is uh, if you have magic numbers and they are effectively supposed to stay static, make a global file
yeah,
and then put those seemingly static numbers, and you'll find out real fast if they're actually static numbers or they get tweaked periodically. But
Yeah.
if theoretically it's like how many frames are in a GSM packet? It's always 8. Okay, cool. So instead of putting the magic number 8 all over your code, have a global variable, and now the node on the diagram is text and the value comes out because you really don't care what the value is. You just need to know that specific
Yeah, no, that's
uh,
actually great. Yeah. Yep. Yeah,
that's an
that's
interesting one.
one perfect application of global variables. Fabiola also likes that constant VIs, which is basically the same thing. You just have a VI that's a constant, and then you get a little icon, but same idea
Yeah.
of just like have it defined in one place.
Mm-hmm.
Yeah.
100%. All right. So in terms of like looking at other people's code and understanding it, you were talking about documentation a moment ago. You talked a lot about mob programming, right? You've done a couple different instances of that. We just had GDevCon. There's the huddles that were at GDevCon, and there was mob programming. And the story that you had from last season was that you allowed too many people to talk. You opened up the floor a little bit too much, too many cooks in the kitchen when you did the mob programming session at last GDevCon,
Mhm.
right? And I think that was for some kind of like, was it was it some opening tool for a project, or like when you open a project, it automatically launches a VI or something?
Yeah, yeah. Oh, so yeah, so those are actually two separate things. So at GDevCon in Germany, which is the one that I think you're talking about, I did a thing where we played like a video game collaboratively to kind of demonstrate mob programming. And then there is the GID exchange is doing some sort of quick open thing, basically where they're doing mob programming. That I was involved in kicking that off, and I haven't been doing that, so I'm not quite sure. I know they did that at GDevCon NA, and I didn't see how it went because I was not there.
Well, you played the game at GDevCon NA.
But
I
we
was
did
merely
the
watch.
game. Yes, we did the game. Yeah. So I did the game, and the idea was I would do the game as an intro to mob programming one day, and
So
the next day
let's
they
let's let's introduce the listeners to what we were talking about here. Because what is this? What is the game that you were
yeah,
playing?
yeah,
Because it looked very interesting.
yeah. Okay. So let's first talk about mob programming, and then I'll talk about why the game mimics it really well. Okay.
Okay, great.
So mob programming in general is this idea of everybody working together, right? So often we call ourselves a team, but we get together and the coach says, great, we're playing basketball. You go shoot free throws. You go shoot 3 points. You go dribble. You go, right? And everybody gets their own basketball court, their own basketball. And we call that a team, right? But that's not
Hmm.
really a team because they're not working together. So mob programming is this idea of everybody in front of one computer, and there's a little bit of structure to it, and everybody brainstorming and working on the same problem. And often people give a negative reaction to measures like, oh, well, how that's inefficient having 4 people in front of a thing. But if you think about it, we do this naturally when there's a problem. When there's an emergency, what do people do? They say, you four, go in a room, lock yourselves in there, and don't come out till you have the answer, right?
Right.
Right? We've all seen that. And so if it works in an emergency, it can work at other times too. So that's kind of the whole idea behind mob programming. And there's some rules and dynamics for how we interact and stuff. And so I got this idea from Woody Zuill. So I totally ripped him off. I'm sorry, Woody, but it was so good. I felt like I had to share it with the world. And hopefully I did it justice. So hopefully you're not mad at me.
Woody who?
Woody Zuill.
Okay.
Ziuill or Zuill.
Ooh.
I'm butchering your name, Woody. I'm really sorry, but if you look up Woody, he's like the guy for mob programming.
Okay.
H in his name too somewhere. I'm sorry. But hopefully he's not mad at me for all this. But basically, I did this thing with him, and he did a demo of it, and I was like, "That is so awesome!" And the demo is really easy. Uh, what he brings to is all the deep insights and stuff. But I tried to mimic that as much as possible. But the game works really well. So the game it's a game called Baba Is You, and you're a sheep and you move around, and it's like it looks like an old Nintendo game. The
Okay.
graphics are kind of flat, and the idea is you move around and there's objects that you can move around and interact with in the world. And there's words that make up rules. And you can change the rules of the game as you go. So you can move the words around to make different rules. And it's great for programming because there's a lot of learning that goes on trying to figure out all the different rules.
Oh, so it's like I think I remember. So it's like multiple blocks, and it's like the floor is lava. Each one of those words, and
Yeah,
then you
yeah.
can
And
move
lava
lava
is
around to be
so if you
lava
step in the
is
lava, you
not real or lava is cool.
yeah, yeah, there's different. Yeah, exactly. It's like that. It's like little 3 word sentences that control how the environment interacts. And as you move them around, the environment changes. And there's a goal.
Got
The
it.
goal is to get to some flag. But the interesting thing is like when you start basically I don't give them anything. I'm just like, here's the thing you can move around. And they start moving around and like they figure out the goal is to get to the flag. And then the next level gets a little harder and it adds more stuff.
But there's only one driver. I think that's the thing that I'm pondering on as a
Yeah.
listener
Yeah.
and somebody absorbing this. Like, at some point in time, there needs to be an overlord, and that's usually the person. How do you pick that person? Is it like
Yeah.
you just let Fabiola always do it, or
Rotates through so everybody does it. But yeah, so you hit on that. There's roles. So there's the driver or typist, the person actually doing the thing, the navigator who's telling them what to do, and then there's everybody else in the audience, okay? And as an audience member, like your job is to pay attention so that when it's your turn, you're ready to go, right?
okay?
You use a timer and everybody rotates. The idea, part of the idea is you have the navigator who's talking and describing what's going on, and they're basically doing the learning. So like, oh, okay, try this, try that. And what you don't want is you don't want the typist to just go off and start doing things because then nobody else in the group knows what's going on. So everything has to be said out loud so that you keep the whole group engaged.
So
Because
interesting.
otherwise
So
the
there's
people in the crowd are like watching somebody move around the mouse and click here, click there, and you're like, well, wait, what did you just do? And why did you do that? And right by the navigator having to say it out loud, everybody's on the same page.
there's a game that Darren Nadinger and his family introduced me to that's kind of hear no evil, see no evil, speak no evil. And it is a challenge to teams, and one of the persons on your team can't see, another one can't speak, and another one
Can't
or
hear.
whatever it is. There's limitations, and
Okay.
you have blocks in front of you. You have a pile of blocks, and you can't see them. So the person that can't see has to manipulate the blocks to make a shape, and the
Okay.
person that knows the shape it's supposed to be in is a can't speak, and the other person that is the person is trying to tell the person who in the blindfold do this stuff, but they don't actually see what the shape it's supposed to be. So
Yeah,
somebody's gesticulating wildly, another person's trying to interpret that and speak it out, and then the other person's got their hand on the parts and pieces
it's
trying to
like a
move.
really distorted game of telephone.
It really is, but it feels just exactly like what you were talking about, but people cycling through the individual rows. So that's very interesting. I'll have to try to take advantage of that the next time that we do that aspect or
But
do the next mob
the
programming.
biggest learning I take away from that, and I always ask this question. So they play the game, they get like, I don't know, 20 levels in. And then I
Mhm.
ask them this question. I say, okay, we all work together as a group. Now, think about how you normally work when you have a LabVIEW project. You give part of the project to this person, part to that person, part to that person, part to that person. If we had done that with this game, and I said, you do levels 1 through 3, you do 4 through 6, you do 7 through 9, would we have got the same amount done in the same amount of time?
Mm,
And the answer is always no. And the reason is because those levels build on each other, and you
yeah.
gain knowledge from doing the early levels that help in the later levels.
Yep.
And that's what we're missing when we all work in parallel. We're not learning from each other. We're not watching like there is a tremendous value even in just pairing, like two people working together. When you work with somebody else, you watch them and you see what they do and you learn
Yep.
keyboard shortcuts. You learn that, oh, I didn't know you could do that in LabVIEW, right? Like anybody who's ever, I've taught the LabVIEW Core 1 multiple times, and it's been a while, but anybody who's ever taught it, I can almost guarantee you will say that at some point they learned something new from the class. They
Yep. Just from
either there's something in the book that they just like glossed over and never picked up on, or like one of the students will do something and be like, wait, I didn't know you could do that. And like, yeah, I just right clicked on this thing and this, and you're like, wait, oh, right. So there's always something new to learn, and you miss out on that when you're working head down on your own computer. Like some people really like that and they feel really productive, and that might be great. And maybe they are more productive that way. But as a team, are you more productive that way? Is the team better when you all do that?
by doing that. I like
Yeah.
that a lot. All right. And so the last question here before, because we're coming up on 2 hours.
Yeah,
I
yeah.
haven't helped anybody who stuck with it, but hopefully it's been entertaining. Taylor, if it's
Yeah.
been entertaining, send us both a Discord message, and we'll be grateful for it. But so the tools you've abandoned, have there ever been a tool that you started using, maybe not necessarily created like your mock framework, but a tool that you were thought was like I was supposed to use this, and then later realized it was completely wrong for you in that. Once again,
Well,
LabVIEW, internal, external.
you stole my idea, but that was the mock framework was definitely one of those tools that I thought I do have some. So uh, that one is one. The other ones are some actor framework stuff. So I wrote like a DQMH style tester for actor framework, and I wrote
Okay.
some tools for unit testing actors, like basically launching them and figuring out how to get messages back. And I don't use either of those. the main reason I always do those is because I don't really use Actor Framework much anymore. So there is that. And then
Is the
also
active framework an example almost of a tool that you're like, I should learn this, and then you just kind of stopped. You're personally chosen to stop in that one.
I am not a great fan of it. People use it and are successful and good for them. And as Christian says, I will say that most of the Actor Framework projects I've inherited, I'm not impressed with, but I will add Christian's caveat that if they were really well done, they wouldn't have called me. So I will say that. But I have inherited some good ones. I've done some work on some stuff from the guys from Zaya, and they do really good work, and I like
Yep.
them. And I've worked with them and used some of their tools, and yeah, it's good. But yeah, the other problem with the actor for doing the DQMH style tester for actor framework, part of the problem is that actor framework changed and went for when we got interfaces, the way you do the
Interfaces.
abstract messaging changed, and I did not do enough actor framework to justify going back and fixing the tool. So that was like tech debt that like I guess you could call it technical debt and that I haven't fixed, but yeah. So and then the mock object thing was something that and I do this sometimes. Like I read books from other programming languages, and I'm always searching for like how are they solving problems. And one way they solved a problem was with this mock object framework. And I was like, I'll go create a mock object framework. And I saw some stuff that James McNally did, and I created one.
Yep, yep.
And I came to the realization that I don't think mock objects are all that useful in LabVIEW. That was one
Right.
reason I abandoned it. And the other reason I abandoned it is because if you really want mocks, Anton Sundquist has a really awesome LMock library that is
Yep.
way easier to use. So any thoughts I had of resurrecting my mock object library when I saw his thing, I was like, yeah, that's way easier. Just do that.
Just go
So
ahead and use it. Well, that's awesome. Well, and kudos to the rest of the community put that in there. All right, so that brought us to the end of question 10. So I think AI did a pretty decent job. Sam
I
actually
was
uttered the
impressed.
words AI can be okay.
Can I say I was impressed? I do think those were good questions. So
Um, so it was, I mean, like I said, but that's like you said, the human in the loop. It's not giving autonomy to the tool. Obviously, there were certain things in there that I caught where I'm like, okay, I saw where it was pulling that through, but I was definitely I try to use it in that way. But rather than dive more into AI at the end of this, because that was we could have done all that. Hopefully, everybody's a little bit more hopeful. I think Sam and like, how did we start off on this one? Right? There's so many different ways that we can go as a LabVIEW community, and if you've hung on this far, clearly you're a diehard. And I think there's a lot of really good things that are coming up. And the idea of us playing together and having these larger conversations. Thank you, Sam, for doing the LabVIEW experiment. I'm just gonna like I'm gonna give golf clap because I don't want to break everybody's eardrums. You and Taylor for driving the LabVIEW experiment for 3 years.
mhm.
It has been the end of season 3, 74 guests total. This one is number 75, so that's pretty awesome. There's 3 bonus episodes and 300 shorts on YouTube, and that's pretty awesome. And the number of times played is over 60,000 noted all-time plays and almost 1,500 social media followers. So that's a testament. This is by far got to be. Oh, that's right. There was the longest running. I remember that from last year's wrap up. It was Mike Avaliotis. That's how you say his last name. He had VI shots, and I think that was the longest running
It's like
one.
74, I think. So I think we're gonna pass it with this.
There you go. We've got it. We finally we
Yeah,
cleared
yeah.
VI shots.
Longest
Now all
running.
he needs to do is start putting more out there. But
His podcast was pretty awesome, by the way. I did listen to all the episodes. So it was definitely.
when was it? When did he stop doing that one? I can't even remember. It was quite a
I
while.
think he was like a lot of it was like 2014, 15, 16, something in that frame, I think. Yeah.
Back in the day before we had gray beards.
Yeah.
Um,
I have a question for you though. I'm going to give you
Ooh,
an opportunity to sell me Nigel. What is the one killer use case? If you said, Sam, try this one thing with Nigel and it will and you'll become a converter, what is the one thing? And I will go try it.
so uh honestly, it has been hardware based, and it's kind of what's an NI thing that does this?
That does what? Like measures a certain like if I'm like I
Yeah,
need
like
okay, so think
give me strain. Like, of course, the NI. So quick plug. Emerson buy an NI. There's a variety of good things about it. They said, here's money, fix your website. We're doing a lot of that. I just did a bunch of stuff recently, and I'm like, wow, that got better. It's going to continue to get better. But in terms of trying to find things, the idea of like just quick searching instead of going to Google, and I'm in Nigel, I'm like, what's the strain gauge or what's the driver? That was one thing that I was like, oh, that was nice. It just spit out the list of things associated with, it was like frequency counters or whatever it was. and that gave me a list.
So
Now, is
so
it
the
100%?
question is, I have this strain gauge. How can I take a reading with that in LabVIEW? And it will tell me this is the card you need. This is the
Yep.
CDAC chassis. This,
Yep.
okay, cool.
That was that.
Honestly, if it does answer that question, that would be good. Because I do remember back in the day, I quite liked the advisors when they actually worked. I think that there's been some. I haven't used them in a while, so on the Champions Forum, I see some of the complaints, so I'm aware that there's issues. But when
Sure,
they
sure.
worked, they were really nice. That you could like, hey, I need a CDAC chassis. I need these modules. These are the signals I need. That whole workflow was really nice when it worked.
Yep. And so Nigel is using information like that to once again make the smarter recommendations. You can ask one of those things of I have an example. I've got a picture. I'd pull it up now if we could, but we're out of time. But the uh hey, what's the difference between this number, this 4-digit number, and this 4-digit number? Right. I put it into ChatGPT and it thought I was talking about Sherwin-Williams paint codes. And Nigel actually figured it out. They're probably talking about something in test and measurement, an oscilloscope from a third-party vendor, and an NI thing, and it gave a base comparison on that one. And that was another one of those. It's building on top of the AI models that are out there to act as an advisor that has the extra dump of NI knowledge on top of it. And I can tell you right now that Darren and I are using it daily. We're leveraging the TSE organization to do it daily so that we're constantly in direct feedback with the people that are tuning it.
So
And the feedback that they are eager for more feedback. So try to use it as much as reasonable for you on that front of it, because that is a huge advantage. Because we're gonna take that feedback and they're like, we're not getting enough feedback at this point. So absolutely dive in on that front. Even if you need to use an older version of LabVIEW, let alone, you can do the project save for previous. But if you don't want to do that, even leaving 25 open so you can kind of use Nigel in adjunct, you can't do a tell me about my VI behavior. But I think another one, Sam, that's going to be a big one in terms of selling for Nigel is that as you engage with people that are using your code or doing a thing, it ideally plays a surrogate Sam when you're not there, right? That idea of if you're learning LabVIEW, you usually have a bunch of questions. Like for me, I'm trying to learn how to program this damn Pico microcontroller, and I'm not taking the time to do all of the learning modules as I've been lovingly told I need to go and do. So I keep trying to use AI to be the smart person next to me to say, hey, how do I fix this problem? What do I do? I'm not saying create all my code for me, but I'm trying to say like, why is this not working and stuff like that. That similar style of trying to have an advisor next to you as you are getting people that you're working with to use LabVIEW, to learn LabVIEW, students, right? This idea of that, trying to get them to leverage that is one of those options. So I've done it for so that's kind of a few of the different selling points for Nigel in that.
cool.
But I've been impressed.
I would say two things quick. One, I like that idea of using Nigel in that way. I think that's good because also it's something you can verify. So if you say, "Hey, hardware do I need?" You can then pull up the spec sheets
Yep.
on the NI website and then verify it. So that's good.
Actually, some of the nice things is it will give you the links in its
Links, yeah, it
response
gives
to
you
take
links
you right
directly.
to
That's
that.
even better. Yeah, yeah.
Pinouts as well.
Yep, cool. Yeah, pinouts are another big one. And then my other question I have for you is you say, and I want some more feedback. Is there a way in Nigel to give feedback, or how do you give feedback? Like if I ask it a question and it does a great job, is there
Yep.
like a thumbs up, thumbs
There's
down?
a thumbs up, there's a thumbs up, thumbs down on the bottom, and then it asks you, it gives you like 4 clickable tags, like, inaccurate, harmful, irrelevant, right, for the thumbs down. And of course, if it was thumbs up, it was, similar, but I've obviously worded a little bit
Awesome.
better. Nobody died, right? That's the first thing that Sam likes.
Cool.
Um,
Cool.
but yeah, that's those mechanisms that you can use for that. And then of course Darren and I are on the Discord and other NIers as well, trying to gather that feedback if it needs to be more of a conversation. But
Cool. Like
yeah,
it.
those things are out there. All
No.
right, so that
Cool.
we'll call it a wrap at this point. And Sam, this has been great. Like I said, there's a lot of great things that you're doing. I think I asked you before we started recording proper, is this the last season for the LabVIEW experiment? And your answer is
No. Taylor
okay.
is
All right.
definitely recruiting people. So
All right.
yeah.
And then I think another part of this is the numbers are clearly reflecting that there are people watching this in the LabVIEW community. So I don't know what it takes to become a sponsor for an individual sponsor portion or more than that, obviously we could say it here, but let's leave it to Taylor. But if you're listening to this and you made it to the end, thank you. But also figure out how to engage with Sam and Taylor driving the LabVIEW experiment and get a sponsor spot. If anything, to say thank you to somebody in the LabVIEW community. Maybe you could do like a different tierings of the sponsors spots, shout out level all the way up to I'm going to take over an episode level of donations to the LabVIEW experiment. And I think that maybe that'd be interesting.
Yeah. This is not free. It does cost a little bit of money to put it on, and we would love some help. Yeah, we can be flexible. So if you've got an idea on how you want to sponsor, what it wants to look like, we can talk about that. So,
Yep. And
well,
there's numbers. I think Taylor's got a PDF that kind of talks through that to
mhm.
justify the investment for, once again, the various different levels that are out there. Or if there's not levels, maybe there'll be levels by the time that you listen to
Yeah,
this.
I know we went through several iterations. We did have levels at one point. So yeah.
That's
Yeah.
awesome. Well, Sam, this has been a great 2 hours spent for me kind of going into this, and hopefully everybody got a lot out of it. And yeah, we'll see you on season 4
Yeah.
whenever that kicks off. When would that be? When should people wait? How long do we have to wait?
Well, we're gonna take like a month off or 2 months off, maybe. So sometime before the
Okay.
end of the year, probably. I know we're gonna
There
decide
you
that on Friday. So
Perfect. All right, everybody. Well, thank you, and we'll see you on the next LabVIEW experiment.
that's it for today's episode of the LabVIEW experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.